But then this another thing came last week. It's these new variants keep coming. So, but yeah, they were planning to open the borders certain people on the 1st of December today, but they postponed it to 15th. But the citizens from Korea and Japan can come, but others, only certain categories like students and skilled workers, there are certain categories can only come. Yeah. But, some states have different restrictions. So people in Sydney can go overseas, but people in Queensland can't go overseas. So I'm in Queensland and I can't go.
Fortunately, India and UK have got no restriction at all for traveling. There's no quarantine, nothing at all.
I start with, do you have some instruction from the secretary?
Shall we start, sir? Professor Nelis? Yeah. Thank you, sir. Okay. Hello, good morning, good evening, and good afternoon, everyone. I, Ikshita Shaha, on behalf of ISWMAW and other partner organizations, welcome all to this plenary session 1 on Asia and the Pacific. It's an honor having amongst us session chair, Professor Michael Nelis, University of Rostock, Germany, and co-chair CRC Mohanty, Environmental Program Coordinator, UNCRD, Japan. He was supposed to be there, but he is in another meeting. So I request Professor Nelis to chair this session. I would like to remind a few points to all present here. All the participants are requested to mute microphone and close camera. Speakers may be unmuted only when requested. Please adhere to presentation duration of 15 minutes for speakers to avoid delay. Question answer will be at the end of the session. Questions should be written in the chat box to specific speakers. The chair individually will rate each presentation on rating sheet provided to you. Chair, kindly write the chair summary of the session with a few key outcomes and present at the end of the session, and send us a soft copy of chair summary to the mail ID IconSWM.CE@gmail.com. I repeat, IconSWM.CE@gmail.com. Filled in rating sheet and chair summary will be sent to us by email. I request all the presenters to kindly confirm their attendance in the chat box. Please make a note. I repeat, all the presenters kindly confirm your attendance in the chat box. I request the chair to kindly start the session. Professor Nelis.
Thank you.
Yeah.
Very pleased that we have a high-level plenary session with topics from Asia and Pacific region. And we don't waste time, so we start with the first one. And it's my old friend, Professor RHEE from the Republic of Korea. And so if you are ready, you can start. It's working, yeah. I think now it's coming. Yeah, very good. Can you go on full screen if it's possible? Very good. So now we can start. Please, the floor is yours. I cannot hear you. Do you have technical problems?
So, Professor RHEE, you are not audible. Kindly unmute.
Go on. You have to.
You are muted, I think.
Okay, it's okay?
Now it's okay.
I hear you.
Okay, thank you.
Yeah, it's okay.
Fine. So Please.
So today I'd like to introduce the new recycling plan in Korea. That is the recycling cluster plan for sustainable plastic waste management. And this is the recycling cluster is planned by large scale of manufacturers also, and several recyclers and the local government and central government, Minister of Environment, working together. Based on the government budget, there is huge amount of budget. There is several hundred million US. So this is table of contents, introduction, challenges for plastic waste management in Korea, recycling cluster plan for plastic waste, expectancy effect on the plastic, the recycling cluster, and then make the summary for that. And first one is introduction. In Korea, the amount of plastic waste was increased from 1.8 million tons in 2010 to 4.0 million tons in 2019. 2010, that is 1.8 million tons here, is 2019, it's go to the 4.0 million tons. The annual growth rate is 9.5%. This is huge amount. The solid waste increased the annual growth rate for municipal solid waste is just 3.5%. It's almost 3 times. So increasing the plastic waste have become an urgent environmental issues such as illegally abandoned waste, marine plastic litter issues, and climate changes. Now, this is the recycling part. This is the incineration. This is landfill. This is recycling is 2019 is about 57%. We have the plastic waste management plan in Korea. The first national plan on resources circulation is started in 2018, just 3 years ago. It's a 10 years national plan to promote the recycling R&D related to waste generation and recycling. Also, there is national standardization and guidelines for quality grades for each type of plastics. Another target is to establish measures for plastic reduction and recycling. Target of recycling is 70% in 2025. The target of reduction is 20% in 2025, and based on the 2018, that is starting point. But there are so many limitations in the plastic recycling industry. First one is small-scale recycling industry in Korea. 5 or less employees is 55%. It's almost 55%. And sales less than 85,000 US is almost 60%. That is the small scale of industry is dominate to recycling plastic waste. And those who want to make a full scale of recycling facilities. Then also manufacturers want to build the test bed facilities. The small business, there are limits on the research fund and manpower to use the test bed facilities. Large business, difficult to build field testing facilities with civil compliance. There's a lot of demonstration to build the recycling facilities in Korea. Also, difficulty in supplying the large amount of plastic waste required a full-scale research. There are so many demonstrations against the plastic recycling facilities in Korea, as the solid refuse fuel plants and another solid refuse fuel plants and recycling center and recycling company. They all the times make a demonstration against plastic recycling facility in Korea. So there are so many challenges for plastic waste management in Korea, and there are several limitations. To solve those problems, so our government, Korean government, want to build a recycling cluster with the infrastructure, network, and technical innovation. The concept of cluster is a geographical concentration of interrelated companies, institutions in a specific industry sectors. Also, the stakeholders of the cluster include related companies, governments, university, research institute, educational institutes. The environmental cluster include a promotion center, R&D center, test bed, commercial plant, and institutional environments. There are several examples of environmental cluster in advanced countries: USA, Germany, Japan, UK. They try to accelerate the clean technology and promote the deployment of sustainable solutions. Also, environmental field. The cluster members is in USA is 118, Germany 87, the Japan is more than 25. United Kingdom is more than 300 cluster members. There are so many advantages of the cluster applications. In USA, is established governance with the government and provision of education and training programs. In Germany, connecting expertise through network between environmental companies. The Japan advantage is support for business mature and market development, obtaining commercialization budget. In UK, it is discovering startups and attracting investment. Those are examples of clusters in environmental field. In Korea, we have built the infrastructure efforts. That is promotion center and R&D center and commercial plant in the recycling cluster. Using this infrastructure, we create an industrial ecosystem of plastic recycling. This is industrial ecosystem get the core functions such as full-scale facilities, technical innovation, R&D funding, building network, education and training, commercialization, and value creation. So that is the promotion center is very important, and to operate and manage the recycling cluster, also support technical innovation in plastic recycling, and promote center build a network of stakeholders related to the plastic industry. And this is main business area in here. Also, R&D center is very important to provision space for research desired by companies. Also, it's built a full-scale reference facilities. We made the survey for R&D plan. It's conducted, and 57 companies wanted to join this cluster. So 57 companies want to join to this recycling cluster for the plastic waste. So among 57 companies and 28 companies wanna get the pyrolysis and gasification. 28 companies wanna make the plastic alternatives. So our government make a plan. First priority is chemical recycling. Second one is alternatives. So in commercial plant, we build the chemical recycling plant also and make the material recycling plant. This is the mechanical recycling plant on here. This is chemical plant on here. So this commercial plant and make value creation through recycling of plastic waste. Also build a supply chain of plastic waste. And so this is the main roles on commercial plant. So what is the expectancy effect? So first one is synergies with adjacent industrial complex. This is the place of recycling cluster and nearby the advanced parts industry on here. Another is the high-tech industry here. Also, there is international affairs technical support on here. So this is the port. It's new port area, logistics and distribution and materials. Also, there is the leisure and recreation part on here. It's the working together. They can create the synergies with industry in various fields. So advantage of plastic waste cluster is strengthening the recycling industry, also carbon neutrality, and realization of circular economy, conservation of ecosystems. So using the recycling cluster of plastic waste, we make the implementation of plastic waste management, increasing the plastic recycling rate as the target is 70% 2025. It's the national plan. Also, the reduction of plastic waste, the target is 2.5 million tons in 2025. So we can make this target in 2025 using and the recycling cluster for plastic waste. So I'd like to make a summary for that. And Korea's plastic recycling industry has limitations such as small-scale recycling industry, demand of full-scale recycling facility.
Professor RHEE, you have 2 minutes more.
Okay.
Okay, thank you.
In build or test bed facility and supply chain plastic. In order to solve these limitations and strengthen the plastic recycling industry, the Korea plans to build a recycling cluster. And recycling cluster can create synergies with nearby industrial complex. And in addition, recycling cluster have advantages such as realization of circular economy, carbon neutrality, and conservation of ecosystem. Because of many advantages of plastic waste recycling cluster in Korea should be established with promotion center, R&D center, and commercial plant. Thank you very much for your attention.
Thank you very much, Professor for this very impressive presentation, what the progress in plastic recycling is in your country. And after the 7 presentation, we have a little bit time to discuss. To this point, thank you very much. And we come to the next one. We have DIVI. He will tell us something about the industrial waste management, a very important issue. And if you're ready, you can start with your presentation and have 15 minutes.
Open J. Sound open J. Hello. Good afternoon, gentlemen. Now, this is regarding the industrial waste management, pre and post generation. The topic today I would like to cover are management of waste before generation and post generation. Management, what is seen and what is not seen, and how the environmental protection starts with actions at pre-generation. Management waste today for a sustainable life tomorrow, fortifying future with futuristic waste management, bringing a dream of sustainable future. DIVI Laboratories Limited, a reputed pharmaceutical company, works towards utilizing experts and manpower, world-class technologies for proper waste management, supporting, encouraging the pre-management of the waste in a structured manner. DIVIs have established a significant benchmark for the industries to follow. The topics that are covered in my presentation today is industrial management of pre and post generation general, municipal waste, a brief review of the present systems and how to simplify, industrial waste, redefining the waste and the environmental protection at DIVIs. A brief review of outlook on waste management being discussed for several years. Waste is always associated with the human society from prehistoric and no doubt will continue into the future. With online shopping type of business deliveries intruding into our lives, more packing resulting in several times more wastage than the product can be envisaged. Waste, if not managed properly, it will deplete the resources for the future generations. The general concept of waste management is to handle it after it is generated, leaving behind the concept of how it can be reduced at the pre-generation. One has to think on reducing the waste before it gets generated. Management of waste has to begin with a vision of waste minimization as a prerequisite. The most effective way to reduce waste output is to reduce the inputs with knowledge, awareness, and to make the process more efficient. The main goal is to concentrate on elimination, minimization of waste before it is produced, generated. This can only be achieved through full knowledge, 3R principles, maximum usage, encouraging the cleaner productions, updating outdated, inefficient technologies with modern equipment and modern technologies, increasing efficiency through methods and protocols for minimization of the waste at production. And these methods help reduce waste quantity in the first place. On this platform, I would like to appreciate IconSWM for its exceptional efforts and events on municipal waste management. 90% of the topics are related to domestic waste management subject only. The other 10% topics are related to industrial waste management, which are more hazardous. No doubt, municipal waste is a serious concern presently, where it is in excess of 2 billion tons on Mother Earth. But industrial waste is highly hazardous and highly toxic. The educating complications on the municipal solid waste, I would like to mention that educating, encouraging, and ensuring segregation at source at the household level is the first step. Sort out waste at the households itself by biodegradable and non-biodegradable. Systems are well in place, but the implementation of these actions are hard to find. Handle all biodegradable waste for manure at origin, that is at residences, colonies, commercial establishment, hotels, etc., or else direct your waste into community bins or pits by segregating them. Treating the waste at neighborhood by the help of residential welfare associations, that reduces the amount of waste reaching the landfill. All the above are very well done in my colony at Visakhapatnam by the residents, and what is picked up by the municipality is reduced to 50%. Management of now coming back to the management of industrial waste shall be given due importance, as mostly it is hazardous, toxic, and goes to the landfill, so-called secured landfill, which is only an isolated location. This is environmentally a very harmful situation, same as with air and water pollution. Through this platform, I am requesting Dr. Ghosh to arrange a separate platform for industrial waste management to showcase the best practices in industries. DIVI's environmental protection gives high priority to waste management, where the word waste is redefined. DIVI's sustainability waste management focuses firstly on pre-generation of waste and then post-generation. Realization of waste is not a waste, but a source of value recovery for benefits becomes a motivation for successful implementation. Interestingly, the word is handled on both the seen and the not seen waste. The concept achieved unbelievable results for the company, both reducing costs and sustaining conservation of resources. Waste is nothing but a byproduct which is already present that can be eliminated, minimized, reduced, and reused by means of rethinking, knowledge, efforts towards better environmental protection. Generally, all of us are talking about physical waste, what we see, which is generated from processes and activities. But if you consider and bother about non-physical waste, which is what is non-physical waste is that's what is not seen. Real important and major management of waste lies in dealing with what that cannot be seen. The picture shows here bifurcation of physical waste, what you see, and non-physical waste, what you don't see. If we go through under physical waste, what we see, they represent the solid waste, residues, sludges, ashes, salts, etc. Liquid waste, solvents, spent, acids, slurries, etc. Wastewater, effluent, sewage, rejected water, etc. Reprocessed, reused. Gaseous waste, recovered, detoxified. Food waste, reprocessed to biomass. General waste, miscellaneous waste, etc. All that what we can see. Now, on the other side, if we see what we don't see, where there is enormous waste, for example, like the time, reduce the time cycles of each operation, which automatically reduce a lot of power and other utilities. Power, it is a major factor. Deep studies to reduce the power using several ecological edges. Energy, heat, pressure, cold, etc. must develop a plan to reduction and reuse. Efforts have to be multiple to achieve results. Manpower reduction, less ergonomics, raw material inputs, mole-to-mole ratios. In effect, we aim at doing less and producing more. We realized that the actions required on post-management are not sufficient. Pre-management efforts has to be more and to be specific. In the ways, as an industry, we specially focus through our initiatives, programs, efforts, and work on identifying and working on subjects related to non-physical waste that cannot be seen. All our actions at industry are aimed to achieve a total quality management, TQM, what you say. We have very successfully implemented several projects on these topics. When you introduce a total quality management into waste management, you see a wonderful results. Through our actions at DIVIs in the last 10 years, efforts resulted in reduction of waste at a generation by 9 million tons of man-days, 9 million man-days, 45,000 plus tons of coal, 200 million liters of effluent generation, 25,000 plus megawatt power, 5 lakh tons of carbon secreted, 1 lakh tons of waste landfill, 9,000 plus liters of water, million tons of solvents, ergonomic actions in millions of counts. These efforts and achievements are enviable and continually help DIVIs to become a role model on the waste management to the other industries. As a conclusion, as an environmentalist, my dream is every individual concentrates more on minimization, elimination of waste, especially waste that cannot be seen, management of waste pre-generation. Likewise, every individual who seems to be a true environmentalist shall think about where to concentrate the effort on managing the waste, whether it is on pre or post management of waste generation. The more effort on pre-generation gives far better results and lead to minimum waste to be managed. Nothing shall be wasted shall be the goal. The above presentation appears as a classroom lecture, but now let me support it by actions and achievements what we obtained at DIVIs. The slide shows to you we have successfully implemented hundreds of initiatives on waste pre-generation, at generation, and waste that is not seen. For example, cool energy recovery. We at several locations, large quantities of cool air from high HP chillers pass through process areas and exit to atmosphere as a single pass. The air at exit is still at 22 degrees. The cool energy is wasted if not recovered and reused. We recover 70% by using a HRU, heat recovery unit. Similarly, direct power saving includes DIVI's power. For example, DIVI's power bill per month is about rupees 17 crores. Several actions increasing efficiency implemented resulting 25% of the power savings. Soft starters, VFDs, high efficiency meters, etc. are implemented. Now, on the reduction of time cycles, reduction of duration in operations, bulk handling of materials, powder transfer systems, etc. These result in multiple waste savings in terms of power, ergonomics, and better safety. Upgrading equipment is one of the most important subjects. Periodically, replace all old equipment with new high efficiency equipment. Lot saving in power, fuel, and low emissions. Equipments like pumps, chillers, compressors, generators, etc. As an example, it is like new motorbike with 75 kilometers per hour versus using an old Chetak bike with 25 kilometers per hour per liter. That will be the difference of the old and new equipment. We go through several crores of rupees of investment on this, not being able to replace a major problem in the other industries today. You invest, you save, reduce the waste, save resources, get back your investment. That leads to profits if you realize. All actions are attributed to waste minimization at generation. All actions are attributed to waste minimization. All savings points out of existence of waste or elimination of waste. One single action leads to avoiding several types of waste. Efficiency is nothing but waste management. That is why total quality management is essential in managing the waste. Action shall be pre-generation, at generation, post-generation, and waste that is not seen. Let us redefine, better understand waste, the resource value. On the conclusion, my actions on the waste management review, I question myself, who am I? Am I an onlooker at the waste that can be seen to manage? Am I a thinker of waste that is not visible? Am I a jnani, a knower who analyzes and minimizes waste before and after generation? Vijnani, an expert who is fully focused on reducing the not seen waste both at the design stage, operational stage, and review very frequently. Only actions and results will define who am I. Thank you, gentlemen. I am available for any queries now or later. Thank you very much, Mikhail.
Yeah, thank you very much, DIVI. A very good presentation and an overview of what we have to do in the field of hazardous waste and special look to the situation in India. So it was a great presentation, and I think we can discuss also after the other presentations. To the third one, we started in South Korea, now we were in India, and now we go to China. Development ongoing in the circular economy, and so I'm very happy that Liu is here and will present the situation. So it's yours. Your microphone is not working, or we cannot understand you. Please check your microphone, please.
Michelle Nellis, we could not hear your voice.
Okay, it's okay?
We cannot hear your voice, sir.
Yes, now we can hear you.
So sorry, I just okay, just it's a little bit a technical problem. Sorry, I just opened my PPT and also let me okay. Can you see my PPT?
Yeah, now we can see it.
Okay, so can I start, right?
Yeah, can you kind of on full screen mode? If it's
okay.
Yeah. Great.
Good?
So
okay.
The floor is yours.
Okay, thank you very much. So, dear colleagues, good afternoon. My name is Zhe Liu from Xi'an University, China. I'm also a adjunct professor at School for Resource and Environment Study in Dalhousie University, Canada. Today it's a big pleasure for me to talk about to give this presentation, circular economic development in China and its connection with the world. And as you know, that the circular economy currently is a hot topic, and more recognized by the governments and enterprises around the world. So today I will give this presentation in China's background, from the following four perspectives, from their policy and law evolution in the past few years, the CE program development in China, and the teaching there, and also the connection between China and the world in terms of the CE development. So first, I have to introduce the background. Why China take the CE seriously in the past few years. So as you know that China in the past 30 years, China maintained a very fast economic growth in the past few years, and currently China is second largest economic country in this world, right? But meanwhile, China, paid, the price for this fast development, fast economic growth. For example, that they have consumed a lot of extensive resources. You can see this figure that here is China consumes around 50 coals resources in the world, and 12 oils, and so on. And also, meanwhile, they generate a lot of industrial waste, municipal waste. Okay, the extensive resource consumption and massive waste generation, and also associate environment, pollutions. So, and you can see, you can hear the report and the smoke, right? Often happens, and also the greenhouse gas emissions. China is largest greenhouse gas emission country in the world. So I think this is the motives behind why China take the CE as a national strategy to to balance her economic development and to cope with the challenges, such as the environment pollution, extensive resource consumption and waste, and also associated environment pollution. So actually, Chinese government has made a lot of efforts, to advance CE development in China in the past few years. For example, you can see that from the law and policy, perspective, the first official, CE law was released in 2009. It's about more than 10 years ago, namely Circular Economy Promotion Law, which means that the government recognized the CE as the national strategies, okay, to make them economic development sustainable in the future. So, and also they released a number of policies to promote the waste recyclings, to promote waste reutilizations from various perspectives. As you can see that this list just demonstrates the policy released since 2016. Actually, they just advanced the CE development from the policy perspective more than 10 years ago. Okay, and actually there are two most important central government departments who are mainly responsible for the CE program. One is the Ministry of Ecology and Environment, and the other one is the National Development and Reform Commission. The Ministry of Ecology and Environment is mainly responsible for the eco-industrial pilot project, and the other one is mainly responsible for the circular economic industrial park. So these two central government departments are mainly responsible for deliver CE program in China. For example, that since 2001, the Ministry of Ecology and Environment approved the first national eco-industrial park in China, in southern China. It was based on a sugar-based industrial cluster. That time, you can see that it's about 20 years ago. They just initiated the first the CE program in terms of eco-industrial pilot project in Guangxi Guigang group. It was based a sugar factory industrial cluster to establish how to establish the network to how to reutilize the byproduct and waste from the sugar factories for the downstream enterprises. And so far, there has been a significant progress in terms of the EIP construction. So far, there are over 150 eco-industrial pilot projects approved by Ministry of Ecology and the Environment. So you can see 20 years passed, and the EIP EIP pilot project, the number of that has been 150. And also, the Ministry of Ecology and the Environment in China released the only one national level eco-industrial park standard in 2009. When was the only one country who released the national level EIP standard at that time, and was most recently updated in 2015. So they use this standard to select the EIP pilot project, okay, to advance the CE program in China. So, and the National Development and Reform Commission also initiated the 33 in total circular economy industrial parks. So you can see the the map of the how the circular economy park are located in China, and the eco-industrial park and circular economy park are similar. They all associated with CE program, but they have their emphasis for each the programs, but they have the common goal, that to reduce promote resource efficiency, to reduce the waste generation. So there are a lot of benefits has been achieved, through implementing the CE program. For example, this is an example only from an industrial park, from an industrial park, in clusters, namely Tianjin Taida industrial parks. And through this CE program, Tianjin Taida also one of EIP pilot project, initiated by the Ministry of Ecology and Environment. And through the CE program, Taida reduce a lot of, you can see that reduce a lot of industrial waste, and also reduce the greenhouse gas emissions, okay, and also other co-benefits. So, and okay, this is from the CE, development in China from the perspective of the policy, the law, and the program. But there is another thing. It's very important that it's to teach the next generation, okay, in order to maintain the CE development. So teach the next generation is very important. So back to 2004, China offered the first course, namely industrial ecology, which was associated with the CE programs, and the Tsinghua University offered the first CE associate course, namely industrial ecology. At that time, about 20 years ago, and so far there has been over 30 universities who offered such an industrial ecology program. Okay, so the other course which associate with CE course is called Resource Circulation Science and Engineering, and so this is a different CE associated course compared to industrial ecology, and this one is more with the emphasis on resource utilization efficiency. Okay, so and this course you can see the list that has been offered by a number of universities in China as well. So you can see that so far there are these two courses which are associated with CE course in China, available offered to students. And from the connection with the world in terms of the development, and I actually China has established a number of industrial, international partnership with colleagues around the world, but they just do it by the local reasons, not coordinated with the central governments. For example, that this example is from the Suzhou Industrial Park. They just established the international partnership with Japan colleagues to promote the waste recycling in that industrial park. And also, I mentioned the Taida Industrial Park. They just carried out the international cooperation and research project with European Union. So to advance industrial symbiosis project. So they just established this industrial international collaboration, cooperation partnership, just by themselves, by the local reasons. They just
sorry to interrupt you, sir. Only 2 minutes remaining.
Okay, thank you very much. So from our study, we have realized that there's no uniform approach to advanced sea development around the world. So as you know that, for example, in EU, in Kalundborg, Kalundborg Industrial Park, Eco-Industrial Park is the most cited case in the world. So which is just initiated by the enterprises themselves. But you can see from the Asia, Japan, Korea, and also in North America, in Canada, the government also play a role in advancing the development. But you can see in China government also make a lot of efforts to direct the sea program, the sea development in China. But however, there are a lot of, so this topic, has a lot of, needs a lot of more further discussions to how to make this sea development sustainable. So we have seen that there are some sea project currently is even though they developed very fast at the first beginning, but we can see that some of them failed. So there are a lot of discussions needs to address the challenges ahead. So thank you very much. Thank you.
Thank you very much for the very interesting presentation about the development of waste management and especially circular economy in China. A great overview, I think. Also, we can discuss after the other presentation. So we come to the fourth one, and now we travel to Vietnam, and we will hear something about sharing economy business models in waste management, especially in Vietnam. And there are many names of co-authors, and I'm very interested to hear in the next 15 minutes the presentation. The floor is yours.
Thank you, Mr. Chair. Can you see my presentation?
Yeah, if you can make it in a full screen mode.
Yeah.
You're on slideshow.
Yes. Okay.
Yeah, very good. The floor is yours.
Yeah. Hello, everyone. And I thank you very much for let us have opportunity to be here today to share with you about our study. And I win on behalf of my research team, and Dr. Tang is the leader of team. He cannot join with us today, but I will share with you the result of our study about sharing economy business models in waste management in Vietnam. My presentation have four parts, and the main part is the overview of sharing economy and waste management, and then I will introduce with you the current situation in SE in waste management in Vietnam, and then some solutions proposed to promote SE in waste management in Vietnam. As you may know, along with the rapid development of the Industrial Revolution and IT system as well as social networks, the sharing economy has strongly developed worldwide in a lot of fields, such as transportation. We have Uber, Grab. In house rental, we have Airbnb, and in finance, we have fintech and many models like that. And in Vietnam, the solid waste management still faces many difficulties and challenges. So sharing economy models with their benefits will contribute to solving problems in waste management through providing quick information on waste supply demand, or supporting connection and transaction between waste shop owners and collection and treatment service providers. And in the coming times, in Vietnam advocates rapid and sustainable development based on science and technology development, innovation and digital transformation. And then the Prime Minister already approved the decision number 999, and one of the goals is encouraging innovation and technology, digital application, and development of the digital economy. So sharing economy models they become important. So we have a study on this. We use some methods to conduct the study. The first is reviewing and summarizing documents related to the SE model. And then we have some in-depth interviews with 6 sharing economy enterprise, and an important agency is the Central Institute for Economic Management under Ministry of Planning and Investment, who is the focal point to manage SE in Vietnam. And the research results have also been consulted with through 2 seminars held in Hanoi in the last August. Overview of the sharing economy and waste management. I would like to introduce the concept we use in Vietnam. According to the Ministry of Planning and Investment, SE is a new business method of peer-to-peer business of an economic system in which assets and services are shared among many users in the market through a digital platform. And in the waste management, as is a business model in which waste, scrap disposal products, waste management services, and as well as knowledge, information, data of waste management is exchanged, purchased, coexist with the support and connection of the digital platform. And as is maybe said that a helpful tool in achieving the goals of a circular economy. Typically, the activity of reusing old furniture through the models of SE. SE in waste management have 3 main features. The first is about the shared objects. We have three types of. The first is the types of waste or products. The second is waste management services, and maybe if knowledge information on waste management. And the SE always use the digital platform such as e-commerce websites, mobile application to share and connect with suppliers, recipients, users of waste, and waste service providers. And the main characteristic of SE in waste management is we need trust between the parties, share objects, trade exchange codes with the participant of parties based on mutual trust. About the classification of SE models in waste management, we based on the international research and the practice in Vietnam, we have divided three types of SE model. The first is connecting model, we can call matchmakers. The second is share resource model, we call commoners. And the third is platform and resource provider model. About the benefits the SE in waste management bring to us, the first is sharing economy promotes the reuse of products and disposal, thereby prolonging the life cycle of products and materials, as well as reducing waste and generation. The SE also promotes waste separation outsource, innovation in collection and transportation, and fostering waste recycling. And the SE models also have to raise awareness, responsibility, and understanding of the community. About the current situation, SE in waste management in Vietnam. Until now, we don't have a lot of SE models in waste management. Through surveys, we collected the information about SE model in waste management, and we divide to subcategories. The first is the model of waste scrap sharing, like Aladdin or Thor in English is give and take. The model is about buying, selling, and giving second-hand goods. Both models operated 2 years ago. And we also have some models are operated by foreign organizations like Share Waste, Oleo, or the Recycling Me. Oleo connects the neighbors and business to share leftovers or non-food items. Meanwhile, Recycling Me is a website to support scrap trading. The subcategory, the second subcategory is the models of waste management services. We have 6 models like Radar, M-Green, Rava, Green Points, and VK. And in which M-Green and VK, they are application platform that connect the waste source owners to buy to sell.
Sorry to interrupt you, ma'am. You have only 2 minutes remaining.
Yeah, thank you. About policies to develop SE model in waste management, we have the policy on digital transformation and sharing economy, and also the policy system on waste management. But the regulation on waste management have not yet mentioned the application of digital platform and SE models. Because I don't have time, so I past achievement in SE in waste management in Vietnam. And here here are some limitations and weaknesses of the SE model. The first is the SE models are still underdeveloped and still face many difficulties in operation. There are still many limitations on policies, on laws promoting the SE in waste management. The market for the recyclable domestic waste is primarily conducted by the informal sector, and the digital infrastructure, waste management infrastructure is still limited, and the financial resources are limited, and people's awareness of waste management is still not high. So based on that, we have some recommendations for promoting SE in waste management in Vietnam in the coming years. The first is integrate regulation on application of SE model in document by law, document plans, and strategy. The second solution is promoting the development and application of SE models in waste management. The third is raising awareness and knowledge of management agencies, businesses, and the community about the sharing economy model through communication activities. The next solutions is promoting digital transformation, develop technical infrastructure conditions to promote SE models in waste management, and the final is the infrastructure condition to promote the SE model should be developed. And thank you for listening. Sorry for late. Yeah.
Thank you very much for the interesting presentation and the overview of the development in Vietnam concerning the sharing economy business models. It was very interesting, and I think there are also some questions afterwards in the discussion. Now we're coming to the fifth presentation, and we going from Vietnam to Kazakhstan. And there we have an expert, Maria KUSSAINOVA, and she will give us a presentation in Agrarian Research University, Agriculture and Reduction of Greenhouse Gas Emission on the example of the Almaty region of Kazakhstan. And I hope she's here. I cannot see her. The Secretariat, do you have some information? Is she here or not?
I think she's not there.
She's not there. So the fifth, we have to skip.
Move to the next one, yeah.
Then we go to the next one.
Yeah.
Okay, number 7. Then we go back to South Korea. And we have another expert from the Chungnam National University. And there we will hear a presentation about waste management and resource efficiency towards a circular economy in Korea. And I think it fits to the first presentation. And so we are lucky that you are here, and hope you can start your presentation, and the floor is yours. I'm not sure she or he is here or not. Question to the Secretariat. Do you have some information about the presentation number 7?
Yeah, in the meeting, I think he has joined, and I couldn't find him right now. I think he's there in the meeting.
Can you unmute your microphone and give us the information you are attending the session or not? Or do you have some technical problems? Then you can write also a message in the chat, so that we don't waste so much time. And then I think we go to the next one. It's the number 8 in the draft of the program, it was the number one. And now we going to Australia. This is from Germany, the other way around of the globe. So we are in the morning and you are in the evening. And I'm happy that you are here, Sunil Herat, and we will hear something about circular economy approach to manage e-waste in the Asia Pacific region. So please, you can share your screen and then the floor is yours.
Sorry to interrupt you, sir. I think Zhang sir is there. Yeah.
It's okay. Then we do it afterwards.
Okay.
Now we
No
hear
problem.
the presentation.
I go now.
Sunil Herat.
Okay. Can you see my slides?
Yes, we can see.
Trying to get them.
If possible, you can. Yeah, very good.
Good, good. Okay, thank you very much, Michael, for that introduction. So the topic given to me, I just get my timing right. So I got 15 minutes, correct? Yeah. So the topic given to me today is to talk about the circular economy approach to management of e-waste in the Asia Pacific region. So what I plan to do is to give a broader picture because as you know, e-waste is a major topic, so it needs a lot of time to discuss in detail. But hopefully I can give a very quick snapshot of what's happening in the region and also what's happening in the region related to the circularity aspect of e-waste. So for us to remind, I mean, we all know this because the e-waste is so popular, but sometimes we tend to forget that you know, e-waste is more than the computers and the mobile phones. So the list here is produced by STEP. There's an organization actually in Germany, Bonn, UNU, as a major organization under Dr. Rudiger, a very good friend of mine. And they have done a lot of reports and work on e-waste. And they have come out with this table, which lists the items which relates to e-waste under various categories. So you can see it is much more than the mobile phones and the computers. So it's basically anything with a battery or a power plug, once it is used, become e-waste. So your toothbrush, your bread maker, you know, everything you call it, it all becomes e-waste when you're finished with it. And of course, lately we have newer waste streams like solar panels and so on, which is also part of the e-waste stream. So you see, there's the variety of items there. So again, the United Nations UNU with the STEP, they produce this report called Global E-Waste Monitor. They produce it every 3 to 4 years, because when you talk about e-waste, there's a lot of estimates you can find in several publications, but some of these estimates are not correct. And they are not highly reliable. But I find this the Global E-Waste Monitor as the most reliable document if you want to look at some data related to the e-waste stream. And they not only look at the current situation, but also look at the future production as well, future estimates. So anyway, so the generation in 2019, according to this publication, the world generated 53 million tons of e-waste. And the alarming figure is that figure is going to double by 2050. So that's a massive increase. And then the other important figure data is that only out of all that, only 17% is formally collected and recycled. So the rest, we don't know where it is going, and most probably it is ending up in open dumps and so on. So the Asian region, again, produces the highest amount of e-waste, nearly 46%. And out of Asia, as expected, we have three major economies, China, India, and Japan, leading the way with the e-waste production. So it is a major, very good picture coming out of this publication to give us why we need to really worry about dealing with this problem in the region. So you can see the apart from Asia, the other regions also have e-waste generation, followed Asia, followed by America, Europe, Africa, and so on. So the interesting thing here is that you can see that although if you take out the part of the world where I live in Australia and New Zealand, where the e-waste generation is quite low, but you can see it has the highest per capita generation. So we are really technology lovers. So as per person, we generate the highest, and also Europe is the same as well. So although Asia produces the highest amount of in total highest amount of e-waste, but when it comes to per capita e-waste generation, Europe and Australia leads the way. So that's the picture you can see from the diagram where the recycling rate is 17.4 and 82%. We don't know where it is going. So so why we worry about e-waste is there are various reasons. Because if you take a computer or a mobile phone as it is, it's not dangerous. You can touch it. You can there's no health and safety issues related to that. But the problem comes when you try to dismantle it. So because e-waste contains a lot of compounds, over 1,000 compounds, and it contains a lot of toxic metals, for example, lead, mercury, cadmium, and so on. As you know, that these metals are now not allowed, especially in Europe, they are not allowed to be used in manufacture. And also they contain what you call the brominated flame retardants, which is the chemical which is used in plastics to minimize the fire danger. So anything treated with those flame retardants will have a fire resistance. So although there is a benefit with that, the negative or the problem is that as you know, the plastic cases containing brominated flame retardants are very difficult to recycle. So the problem is there. So if you don't manage these compounds, manage these items properly, then we have a major environment and health impacts, which we have seen in countries like China, India, Africa, and many places where the informal waste recycling sector is very active. So apart from e-waste being a problem, the e-waste also is an opportunity, and you can see that for example, if you take your mobile phone, it can contain a certain amount of very valuable metals like silver, gold, and palladium. And the electronics makes up about 80% of the world demand for indium. So all the precious metals are there. And the UN estimates that in 2019, the value of e-waste is around about $57 billion US, with iron, copper, and gold, and aluminium leading the value chain. So because of this, e-waste is now regarded as an above ground mine, because as you know, all these metals you need to go underground to mine, but now we have a above ground mine. And especially this is a good news for businesses who can make a business out of these materials, because these are valuable materials to recover. So the message is that although e-waste is a problem, it is also an opportunity. So so how you deal with this? If you look at the circularity side of things with e-waste, of course, the first thing we can do is to reduce and reuse based on the 3R principle. this is something very hard to convince the public, because the moment you get the new version of the iPhone, we find a long queue in front of the shops. So we tend to, although we talk about reducing and reusing, that is one of the most difficult things from a community point of view to achieve, because these newer designs and publicity coming from marketing area is very high in those items. So we tend to replace our electronic items before, well before their end of life is completed. And the next thing, of course, is to, if you can't reduce or reuse, then of course we need to recycle properly. And this is, as you know, is again a complicated area, because most of the e-waste in the world is recycled by what you call the informal sector, because it is very expensive to recycle in advanced countries. The tendency has been in the past to move those items into countries where there's cheap labor and also lower environmental regulations. So that is not a way to go. And the Basel Convention is, as you know, the Basel Convention is the organization looking after the transboundary movement of hazardous materials, and they are looking at this issue very seriously. Then, of course, the next thing we can do is, of course, to go upstream, which is a very important part, because if we can do something to avoid the e-waste, then we have sorted out the problem to a certain extent. So the design and manufacture the electronic items with less toxic materials. As you know, we call it design for environment, design for sustainability, and so on, green design, green computing, and so on. This is happening in a major way now. There is a lot of R&D happening in countries like Europe, Japan, and so on, where they are researching on alternative materials, alternative toxic materials for these toxic material inputs. And of course, the regulations are in place to also to encourage that. So, and then the next thing is, of course, the most popular management method is the implementation of EPR, which is the extended producer responsibility. And as you know, the EPR means that the producers are physically and or financially responsible for the environmental impacts. So basically, what that means is that the producers cannot finish their responsibility after selling the product. They have to take back the product after the consumer has used without any cost to the consumer. So that's the expectation. And through EPR, the other expectation is also that because the manufacturers need to take the product back, there is an expectation that the manufacturers will attempt to produce quality products so that it will last longer and so on. So the EPR is being implemented in many countries. This was led by the advanced countries.
Sorry to interrupt you, sir. Only
Sorry?
2 minutes remaining.
2 minutes, yeah. No, I started at 9. Okay.
Yeah, take your time, sir.
The Australian example is one example I can give you. Unfortunately, I don't have time to go through, but this is done through what we call PRO, the Producer Responsibility Organization, where all the manufacturers, all the importers will have to pay a fee, and then that fee is used to properly recycle the e-waste. And then this is another example from Singapore, which was recently established, the PRO. Again, it is the same model where the manufacturers will pay a fee to the PRO, and then the PRO will use that fund to properly recycle. So there are many other examples from Japan, China, and so on related to EPR systems. And India is another good example of implementing EPR. The rules have been revised in 2018, and you can see the major concentration on e-waste management in India is based on EPR. So I have done some work on looking at which countries have implemented the EPR and categorize them into three areas. So the full implementation is done by countries like Australia, China, India, Japan, and so on. Partial implementation done in countries like Bangladesh, Cambodia, Indonesia, and so on. And there are also some countries where there is no EPR regulation, but they are managing it with the other regulations. So finally, I just want to look at the way forward. We talk about the Sustainable Development Goals, and we have within those goals we have certain targets, as you know. And what I have tried to do here is to try and link those targets to some of the things we have to do, some of the activities we have to do to manage the e-waste stream. For example, to eliminate the hazardous substances during production of e-waste, electronic items, relates to the target 3.9. Eliminate open dumping and open burning of e-waste relates to 12.4, and so on. And I think the most important thing is to design the last one, which is the design electronic items with circularity in mind to prevent e-waste generation at the end of life and implement EPR systems, which is directly related to 12.5. So that's pretty much it. And I want to finish with two very quick questions, which relates to how do we enable the environment for the private sector to harness the potential for business and economic opportunities. That's one challenge we have. The other thing, especially in the region, is that how do we combine the strengths and the capabilities of informal and the formal risk sectors to develop a sustainable e-waste management system? This is a very important question to answer in the region. Thank you very much, and that's my presentation.
Thank you very much, Sunil, for this very interesting presentation and the overview about the Asia Pacific region with a focus on management of e-waste. Very interesting, and I think also some questions are coming after the last presentation. The last presentation are now coming from Korea. We started with Korea and finished with Korea in this session. And I'm happy that Yong-Tui Yang is here from the National University. And he will tell us something about waste management and resource efficiency towards circular economy in Korea. So if you are ready, you can share your screen and start with your presentation. The floor is yours.
My name is Yong-Cho Jang from Chungnam National University, and my title is Waste Management and Resource Efficiency toward the Circular Economy in Korea. And I'm happy to present my topic today, and I really enjoyed all your presentations. And you may know the Korea has a very high population density with a small, relatively small area, and we heavily rely on imports of most resources, almost 95% from out of country, and so the circular economy is a very important topic, and we are making a lot of efforts transitioning from linear economy to circular economy by industrial innovations and social infrastructure change. are currently underway, and as a part of circular economy research, I'm going to present some resource consumptions and resource productivity and resource circulation over almost 20 years by using material flow analysis. This is kind of a big overview. We have some system boundary and a lot of resources out of country, and then you will all materials consumed in this boundary area, and then we consume those materials and resources, and eventually some resource and materials will be lost or converted to energy or incinerated or landfills. And some material finally can be recycled going back to production stage. So this is kind of a big picture of resource efficiency and material flow. And when we evaluate this resource productivity and resource efficiency, we use a lot of database and reports and national statistics and a lot of inventory data we use, and I will show you some data. And domestic material consumption is basically, we import a lot of natural resources, and also we import products, and we also consume the domestic resources. So using those domestic or material input, that we take out some, export volume. So using those concepts, we can calculate the how much resources and material consumed in Korea in a system boundary, and we in order to evaluate the resource efficiency, there are two major indicators. One is resource productivity based on domestic material consumptions over GDP, and if this resource productivity is high, that means using a certain amount of material consumptions, we can create more strong, like gross domestic products. And the second, the big indicator is resource circulation. So using the total material input, how much the recycled product going back to the industry. So, and we use these two indicator, and then I can present some of the trend in my slide. So let's take a look at the evaluation of resource productivity over the 20 years, almost 20 years. So starting 2000s, we start as 2000 as 100, and then over the almost 20 years, the GDP growth almost doubled, and also domestic material consumption increased 1.2 times. And then using those trend, we can estimate what is the resource productivity. So from this almost 20 years, the resource productivity increase about 60%. So, and we can define the over the 20 years, we observe the decoupling occurred in Korea between 2000 and 2018. And then this is resource circulation evaluations. And starting 2000s, as you can see on the blue line, is it increased almost 70% increase by recycling, while the landfilling rate is almost 50% decrease based on domestic material consumptions. And you can see the big recycling is keep increasing, and the landfilling is keep decreasing over the almost 20 years. So, and this is the big material flow or resource flow analysis in 2018. I'm not sure as you can see or not, but a lot of resources and products coming from outside. So you see the almost 600 million ton outside. So this is the import volume, and then domestic research only almost 30% coming inside from the Korea. So a lot of materials resources coming outside of Korea, and then some fraction by exports of products and materials, and the energy consumed is this much, about 326 million, and then net stocks like buildings and then a road and all the constructions might stop, and then car and metals, things like that, and then almost 137 million is recycled and going back to the industry, as you can see in this table. But only 12 million ton of waste disposed in landfill, and 9 million ton of waste were burned in 2018, as you can see. And I compare the Korea and Japan, and then in this table, population is almost 2.5 times larger. Japan is larger than Korea. Area, as you can see, also almost 4 times higher than and Korea, Japan. Then our resource circulation rate as a percent is 13%, as compared to Japan is 15%. So we're still a little bit behind. As you can see, also resource productivity is 3%. I mean the $3 million per 1,000 tons. So you can quickly get some idea how our resource efficiency and resource circulations achieved as of 2016. And in the future, we are still making a good progress. I think at the end of this year, we will be announce Korea Circular Economy Action Plan. There has been efforts from how to promote resource circulations and net zero declarations and Green New Deal and things like that. So I think this year is going to be a big turning point for Circular Economy Action Plan, and the government will present next 10 years how to promote circular economy. And this is a kind of a vision of Circular Economy Action Plan. And then we do have 7 key sectors, key area, like packaging and plastic and textile and electronics, we're kind of making some kind of a good comprehensive plan as well as a detailed roadmap of each sector. And then, so by implementing this circular economy, ultimately will achieve a zero waste society and carbon neutral society and almost complete resource circulation. So we are targeting. So you can see the this vision and then key area. Okay, so as a summary, I present almost 20 years how resource productivity has increased, as well as how resource circulation rate has been increased over the 20 years, and resource circulation has been almost 50% increase, and resource productivity as well increase, and K circular economy roadmap and action plan is currently underway, and then we are kind of a push forward toward the circular economy with various measures and regulations, so that we can achieve the 250 carbon neutrality in Korea. Okay, I think this is it, and thank you for your attention. I'm happy to answer any question if you have. Thank you.
Yeah, thank you very much for the very interesting presentation. To finish this session with, in general, 6 presentation. And now we have enough time to discuss. And I took a look in the chat. There was a more general question. It's more to the Secretariat, I think. There was a question if the presentation can be sent to the participants. Can you tell us something? What's the plan of the organizers?
Sir, as per the chat box, there is no question. So we just you, if you have any questions, we can
Roy, can you say once more? There was a little bit noise in the...
Okay, sir, as per the chat box, there is no question to any specific speaker. So all the participants, or if you have any questions, so that you can communicate.
There was one general question in the chat. The presentations, the files as a PDF file, is it organized that they can send to the participants, or should they keep in contact to the participants? Hello?
Yes, sir. Can you repeat, sir?
Yes. There was a general question in the second announcement in the chat from ISWMAW from Vietnam. She also gave a presentation in the session. Can we have more presentations today? This was the question, and therefore we need an answer. Or if this is not planned, then they have to keep in contact with the presentators, and I think then it's not a problem to get the files.
Yes, sir. Today in this plenary session, we don't have any other presentation. Dr. Soumyajit Roy confirms, sir, he is having another session presentation from 6:50 IST. Yes, sir.
Okay.
I have a question for Sonia Harry.
Yeah, sure.
I think Professor Sonia Harry raised the 2 major questions. So, Sonia Harry, are you there?
Yes. Go ahead. Yep.
Yeah, I think he made a good key question. So, how to integrate the some circular economy of e-waste from informal sector in developing country with the some kind of a formal sector. I think a lot of e-waste managed by informal sectors in developing country, but using some kind of a EPR system, it's not easy to adopt simple or very complicated EPR system used by developed country or like high income country to low income country. So, you know, do you have some kind of a good insight on how to solve how to accelerate the circular economy of e-waste in developing country by using the concept of EPR system? That's my question.
Yeah, no, it's a very, very good question and very timely question because as you rightly said that some of the the EPR is currently working very well for advanced countries, but the mistake which is going to happen, which might happen, is that if the developing countries try to copy the same model, that will not going to work. Because EPR depends on, of course, finding the producer first, and also getting the producer to finance the system. So the issue is very complex in developing countries because, as you know, the e-waste is handled by the informal sector, and then if you try to locate or if you try to commission a formal sector, the problem will be that the formal sector will not receive the goods because the informal sector takes away all the e-waste. So this is something where we need a real dialogue to happen in developing countries, to get the informal sector and the formal sector in the same table and see how we can synergize the activities, because the simple fact is that we cannot ban the activities of the formal sector because that is going to be a social issue, and at the same time we cannot allow them to proceed to every level of e-waste recycling, because what I'm trying to say here is that the informal sector is very good at collection maybe and also a little bit of dismantling, but they are not very good at the formal extraction of metals where you need the advanced technologies. So in developing countries, maybe there's an opportunity to use the informal sector to do the collection part and the little bit of dismantling part, and then to use the formal sector to do the advanced facilities. So one way to do this is to see whether you can develop a partnership between the original electronic manufacturers with the informal sector in developing countries, so that the difficult part of the recycling can be imported to the advanced countries. So that's one model to look at. But as you rightly pointed out, this is a challenging issue. It's not a simple task of implementing EPR, or in other words, not a simple task of writing the document regulations and then trying to implement it.
Yeah,
thank you very much for the question. Also the remarks. I think the suggestions are also in the right way. We have the same experience that it's not so easy, and therefore we have to work together, formal and informal sector. And I think this is also the meaning of the participants.
Yeah, international cooperation is very critical, and because especially developing country is they have a very limited financial resources. So Samsung should be invest. They should be take more responsibility, take some kind of leadership and how to solve this waste problem based on polluter pay principle. That's what I suggest. But we can't just simply ask help. But the developing country also need to be understand and ready to for all the regulations and measures and partnership and things like that. So that's my. I think Sonia Harris, you have a good comment and good insight.
Yeah, thank you very much for this additional remark. I will come to Professor RHEE, also from Korea. It was very interesting to see how you build up these cluster solutions. You mentioned a lot of challenges. What is the main challenge from your point of view? Because we try the same in Germany, and there's a lot of difficulties we have to come over. Professor is also here, or he is gone. I don't know. If not, yeah.
In Korea, I got the main challenge is related to social works. It's the civil demonstration. It's against the build the recycling facilities. That is the first one. We was so short capacity to recycling plastic waste. So that is the government involved to build the recycling cluster. Huge amount of budget. So that is the reason. A lot of the recycling, plastic recycling waste is going to cement industry in Korea.
Yeah.
So also there is a lot of illegal amended as plastic waste. CNN make the broadcasting about in Korean some place to abandoned plastic waste. So also some plastic waste is going to the some other countries.
Yeah.
So that is illegal. So there is a problem to build its recycling facilities.
So you have the same problems we have in Germany and the same discussion, I think.
So I like to make a recommend to India, China, and other countries build the recycling facility at first before the demonstration.
Oh, so then I will come to DIVI. This was a great overview what is going on with industrial waste and hazardous waste, especially in India. What do you think must be the next first step to go to a sustainable handling with industrial waste in India?
Yes, sir. Yes, Michelle. As mentioned, actually, see, most of the waste of the industrial waste, because the industry has assumably some technology with them, some knowledge with them. But many a time, unfortunately, this knowledge and this technology is restricted to the production where they want a product. They will go to any extent to develop it. Unfortunately, when it comes to waste, nobody wants to waste their time. This is the problem, number one. Number two, the industry are not experts in handling the waste. They exactly do not know how hazardous it is or how dangerous it is. So what is required is first a knowledge bank of developing what is waste, how to look at it, what is the later on effects of it when you dispose. My subject here is it is better handled even before the production or before the generation. Develop enough technology where you identify what is the possible waste before even the action begins of production or in industry. Industries shall be made responsible to identify the waste coming out of the industry at the generation and what they can do to minimize the waste there or segregate the waste there or to handle the waste. Incidentally, what I have forwarded is a waste that is not seen. This is very important. This is a big drain on resources of the country. What you don't see, you consume excess power, excess energy, you consume excess manpower, you consume excess time. We at DIVIs have specialized how to look into this in depth. When you look at it in depth, you will identify where are all the wastes getting generated. What you don't see, when you correct it, when you attend on them, it will automatically result in the physical waste becoming much, much less quantity to be handled. I also encourage to get quality into management of waste. When we are being a pharmaceutical company, the quality and quality management becomes the highest order requirement, also the quality assurance. When we take these subjects of total quality management into waste management, this is like giving it equal importance. That's why we call in our company environmental assurance. With this approach towards the waste, you respect the waste first of all. You look at it as a source of money. Once you do that, after all, businessman, he wants money. If there is a source of money, he will move towards that. It's only a matter of realization that waste is a matter of heap of currency notes to be collected back. This is the approach of all this. Waste means knowledge first is more important. The intention is important. The effort is important.
Yeah, thank you very much for this important remarks. And there are some points you mentioned. We also thought 30 years ago in Germany, in my study program, I learned we have to think about the waste after the production before we start the production. But in practice, we are not on track to do it also in developed country like Germany. So there we have also to do some homework. I look at the time, and we have 4 minutes to finish the session, and I have a lot of questions to all the participants. But one short question to Professor Liu. I worked for more than 15 years in China, have some guest professorships, and it was very interesting to see how fast is the development in circular economy. What do you think is the main next step for China in a circular economy?
Actually, as you mentioned, that China has made a significant progress in the past 10 years in terms of CE development. I think the next step is to how to make the existing CE projects sustainable, okay, and also how to promote some CE project. I think it is bad because some CE projects currently it seems that's not as active as the beginning, because as you know, China's the main developer CE program is by governments play a very key role in advanced CE program. Okay. But also, there are a lot of enterprises they involve in such a program. But if the government, don't involve in such a program, so how's going on in the next? So I think this, I think this is a very good topic to discuss about that, because this approach has its advantage at the first beginning, because some CE program needs a lot of investment at the first beginning, at the early stage. And if governments have them, it may succeed. But how to make it sustainable in the future? I think this is a very topic that we can further discuss. And can I respond a little bit for the last issue regarding e-waste? Just a very short comment on that. And okay.
Sure.
And yeah, I think the biggest issue for developing nations to deal with the waste, or maybe reusing the waste, is that the biggest issue for that is they are lack of the sanitary facilities. So there we have learned that such as the e-waste transfer from the high income countries to developed countries to Europe to Africa, and made a lot of environmental issues there. But why? Because they lack of the sanitary facilities to deal with the waste. So how the ESP function in this regard? We have to discover. If even just we have some ESP mechanism, how to enforce it. I think this is a big issue ahead.
Thank you
very much.
Additional comments, also very important, and I have to take a look to the schedule, and we have to finish in 1 or 2 minutes, so I try to summarize a little bit about the session. For me, it was very interesting to chair this session because it was a trip around Asia and Pacific to different topics of waste management. We started in South Korea and finish in South Korea. We heard a lot of development of circular economy in general in South Korea, with a focus on plastic and also on e-waste on the other hand. Then we heard a lot of interesting development issues about handling of industrial and hazardous waste, especially in India, and what we have to do in the future. We get a deeper insight of the circular economy development in China. We have also deep information about the topic of sharing economy business models in waste management, focus on Vietnam. And also we got from Australia a good overview about the circular economy approach to management of e-waste in the whole region of Asia Pacific. So I think it was a very interesting session. I have to thank to all the presentators and also the half hour of interesting discussion. And if there is something from the organizer to mention, now is the right time for this. Is there something?
Organizers, please. Yeah, it's really nice presentations by different people, and you know that as Neles was mentioned, that we started with Korea and finished with Korea. In my speech on Asia and the Pacific, everywhere throughout the world, a portion of my lecture will be always on South Korea's performance. And you know that South Korea in 1980s, it was same like other developing countries, the waste management. But the way they have developed through their recycling society and many other resolution, rules, regulations, and it is really amazing that by 2020, they had a target of reaching only 3% of the waste to go to the landfill. And the rest of the waste is to recycle. Of course, the pandemic was a bar, and I'm quite sure in next 2 to this time, they can reach that 3% or 4% of it. Of course, now it is also very low. It is around 12 to 15% of the waste which is going to the landfill. So, and I visited many of their facilities, waste to energy facilities, and moreover, the facility which is really very daunting is in only some of the countries is there that if you put your waste in a bin and that with a pipeline and vacuum directly go to the waste treatment facilities. So that is not in many numbers in South Korea, but it is still there over there. So it is really very, very exciting and interesting. Of course, China is doing well nowadays. I also visited number of facilities. We have many things to say about Australia, and our friend Sunil is doing a lot of work with respect to the waste management. India, very big country, India and China, but still India and China, whatever they're performing with respect to the waste management is encouraging for the developing society. And specifically in India, which I was to speak something in my keynote speech, but my voice was cracking and I had some administrative work. So you know that from 2014, in India, we have started a new journey towards waste management and circular economy through the Swachh Bharat mission, through revising all our waste management related rules, and of course the Swachh Sarvekshan. Each year from 2016, we are taking the survey and the assessment of all the municipalities, which started in 2016 with only 75 cities. And today in 2021, we extended that to 4,300. I can't remember the number, but it is more than 4,000. So that is the way India is moving forward. I'm quite sure that in next 10 years' time, if we go like this, then India can be comparable in a comparable stage with respect to the European countries, Japan and Korea in the waste management and circular economy scenario. So with this, I once again thank you, all of you, very much with the chairmanship of Neles. Neles is a very, very effective person. We visited many times together to China and other countries. He is also in India. And you know, from the very beginning of this ICONS movement, he is with us. And he's a very effective member of our IconSWM, like our Lifetime Achievement Awardee, Professor RHEE. RHEE was awarded in 2018 or 19? RHEE?
18?
2018. So he was the first group of Lifetime Achievement Awardees in IconSWM.
Thank you.
And we're sitting with the newly Lifetime Achievement Awardee, Dr. Rao, Mr. M. Rao, Divis Rao. So with this, I believe that now my secretariat will request all of you to show your very beautiful face in the camera so that they can make a photo for you. So all of you, please show your face in the camera. Dr. Rai, yeah. So take the print screen. Yeah, please show us your face in the camera. Put on your camera, Marvat, Hilda. Wait, Marvat. Marvat, I saw your very beautiful face in other session, but why not here? Munikusmi, show you. Kachikoti Panda from Zambia. Pankaj Chauhan, Noor Alam from Bangladesh. Yeah, please. Okay, now we are taking a photograph. Yeah, Hilda is here from Hungary. Okay, thank you very much. So see you again in the next session. Next session will start at 6:15 and be with us for next 4 days. It will be really good. And yeah, thank you. Thank you.
Thank you.
Bye.
Thank you. Bye, everyone.
Bye.
Thank you, Neles.
Bye, Dr. Sandeep.
அதான் கேட்குறேன். மெரினா பீச்சுன்னு போட்டா போதுமா? அது போல நிறைய இருக்கா? மெரினா பீச்னா சைடு போயிட்டுருக்காங்க. இங்கிருந்து ரோடு ஒரு ரோடு மலையாளத்தில் போகிறோம், ஒரு ரோடு சாந்தம்பரம் போகிறோம், ஒரு ரோடு திருவாரூரில் போகிறோம். அந்த மாதிரி ரோடு சொல்லி ஜாயின் ஆகணும். சரி, அது மட்டும் மெரினா பீச் தான். ஒரு மெரினா பீச் 2 கிலோமீட்டர் இருக்கு. 2 கிலோமீட்டர் 3 கிலோமீட்டர் இருக்குது மெரினா பீச். சரி, எங்கே இருக்காங்க? 51 ரூபாயாமா? 51 ரூபா புள்ளி. அன்னைக்கு 40 ரூபா, இன்னைக்கு 51. மோட்டர் சைக்கிள் மோட்டோ ஐ மீன் 2 வீலர் 25 ரூபா தான். அவன்கிட்ட என்ன கேட்கறதுக்கா? டேய், என்னடா கேட்கறது? நிறைய இருக்காதா? இதுவே எனக்கு ஏழா சொல்லி கொடுக்குறீங்களா நீங்களாம்? என்ன சொல்லுங்க, மெரினா பீச் நிறைய இருக்காமா? மெரினா பீச்சில் எந்த லொக்கேஷன் சொல்லு. சமாதி பார்க்கவா? யார் சமாதி? யார் சமாதி? நான் அவளை கிண்டல் பண்ண சொன்னேன். சரிடா சரிடா. டேய் போகுண்டா, வாய போடுறான். டேய் நான் உன்னோட சும்மா அவனை கிண்டல் பண்றதுக்கு கேட்டேன். யார் சமாதி? சரி, அதான் எங்க வருதுன்னு சொல்லு. எவ்வளவு நேரம் இருப்பீங்க இங்க? இன்னும் 1/2 மணி நேரம் சமாதியில. அரை மணி நேரம் சமாதியில இருக்காங்க. சரி சரி, நாங்க அங்கேயே வர்றோம். அங்கேயே வரோம், இருங்க. அங்கேயே வரோம்டா, இருங்கடா. அதுக்குள்ள முடிக்கணும். கம்யூனிகேஷன் ஸ்டேட்டஸ் மட்டும் தான் பிரேக் ஆகும். எனக்கு எங்க லாஸ்ட் 2 days போடுது. அது மட்டும் தான் பார்க்க சொன்னாங்க. அம்மா சொன்னாங்க. எல்லா காலையும் சொன்னாங்க. ஸ்லைட்லாம் பிரேக் ஆகல. கம்யூனிகேஷன் ஸ்டேட்டஸ் மட்டும் தான் பிரேக் ஆகுது. இங்க வேற ஆமாண்டா. எனக்கு இது என்னதுடா? அந்த அந்த இடத்த மட்டும் அப்படியே ட்ராக் பண்ணி பாருங்க. அது என்ன டைமிங் பாருங்க. கம்யூனிகேஷன் இல்லையா? ஆமா. டேய் ஆகுதா? ஏய் லாஸ்ட் பிரேக் ஆகணும்ல. பிரேக் ஆகலன்னு போடுங்க. பிரேக் ஆகலன்னு ஆமா பிரேக் எங்கடா பிரேக் இருக்கு? பிரேக் ஆகல. அதான் சொல்றேன். கம்யூனிகேஷன் ஸ்டேட்டஸ் மட்டும் மொத்தமா செலக்ட் பண்ணிட்டேன். அப்படி பண்ண கூடாதோ? பிரேக் ஆகணுமா? ஆகணும்.
We'll be starting within 5 minutes. Session. We will be starting within 5 minutes. Please wait. We will join you shortly.
All right, yes, sir. Hi, good evening. Good evening to all of you. And namaskar, my name is Sadhan Ghosh. And you know that, namaskar. And you know that Professor Francesco Di Maria, our friend from Italy, he has an urgent call from his either university or somewhere, so he's he is indisposed for our program, so he may be attending in some other days. So as he was the co-chair with me, and you know that I have to control all these 4 rooms with my secretariat, so that's why I requested Professor from Tezpur University, my colleague and my co-researcher, Professor Devendra Chandra Borua. So I welcome him, and he is from Assam. Assam is the northern part of India, and it's very beautiful part of India. So you should join and you should visit sometime. And Devan is a very good researcher, and he is a professor, and he was the head of the Department of Energy in that university. So I request Devan to be with me, but I have to go frequently here and there in different 4 halls. So mainly Devan will carry forward this session with the speakers. So I like to request the first speaker. Okay, first I like to hand over the secretariat to say something, because they have some points, and then we will start. Devan, it's okay? Are you accepting it?
Fine for me. Perfect.
Thank you. Okay. Chalo. তোমরা বলো। Start করো। তুমি বলে They will move to the other side.
Yes, thank you, sir. A very good morning, good afternoon, and good evening to all of you present here. I welcome all to this plenary session to European and East Europe. Myself, Tuli Roy Chaudhary, on behalf of ISWMAW and other partner organizations, welcome all to this plenary session 2 on European and East Europe. It's an honor having among us the session chair, Devendra Chandra Borua, Tejpur University, India. And I would like to remind a few points to all present here. All participants are requested to mute microphone and close camera. Speakers may be unmuted only when requested. Please adhere to the presentation duration of 15 minutes for the speaker to avoid delay. Question answers will be at the end of the session. Questions should be written in the chat box to the specific speakers. The chairs individually will rate each presentation on rating sheet provided to you. Chairs kindly write the chair summary to the session with a few key outcomes and present at the end of the session, filled in the rating sheet. Chair summary will be sent to us by mail. I request all the presenters to kindly confirm their attendance in the chat box. Please make a note, I repeat, all the presenters kindly confirm your attendance in the chat box. I request our chair, Devendra Chandra Borua, sir, to kindly start the session. Sir.
Thank you very much.
Thank you, sir.
Tuli Roy Chaudhary. Really impressive announcement. I hope everything is clear. And now I request your all presenters to start the presentation as per the instructions given from the Secretariat. The first presentation, I hope it's by Nellis on this organic waste and residue in Germany.
Okay, thank you very much for the nice introduction. I try to share my screen and I hope it will be working. So I hope everything okay. You can see it.
Yes, yes.
Then I will start. I think I have 15 minutes to give you a short overview about the topic of organic waste and residues in Germany. If you are interested, I can send you also the PDF file about the presentation. There's also a longer version, so you get only some insights. Unfortunately, I have to leave after my presentation because I have another important meeting here in Germany and I can't skip it. But if you are interested, we can keep in contact. You can see here two organizations. So the personal background is on one hand the University of Rostock. It's a middle-sized university in Germany, and we are working at the Faculty of Agricultural and Environmental Science. And we have the topics waste management on the technological part, international activities. 2/3 of our projects are abroad, and also in the Asian region, China and India are main focus areas. And bioenergy is a link to the German Biomass Research Center. It's a German center for all the issues with biomass and especially the organic waste and residues. There are working 250 employees at this center. In my group in Rostock, we have 40 to 50 experts in the group. I will share with you some information about Germany, and I have three main parts. I will start with biomass in the energy system of Germany. And you can see here the main parts we focus on the left side, the energy crops. This is not part of this presentation. I will focus on the middle part and the right part, the organic waste. You can see some examples and also byproducts and residues in the agricultural and forestry area. Biomass in the German energy system is a complex field. You can see here, this was also the reason in 2008 to set up the German Biomass Research Center in Leipzig, because we have a lot of different substrates you can see in the above part, and I will focus on the residual products and waste part. Then we have the biomass supply, logistic, and we have a lot of possibilities to convert biomass in energy. And then we can use it in different areas for motor fuel, electric power, or heating or cooling. So we can do everything, but not everything is sustainable in this area. You can see here the primary energy consumption in Germany. Here's the year 2017. And in Germany, we have the goal to reach 100% renewable energy system, and you can see that there's a long way to go. In 2017, it was 30%. In 2020, we have roughly 15%. But you can also see the main part is based on biomass. If you take a deeper look to the renewable biomass part, and biogenic waste is also included, so these are roughly 8%. This is a chart. You can see the greenhouse gas savings we based on renewable energies, also the year 2017 as an example, and the green parts are summarized up to 64 million tons, and this is the biomass-based renewable energy part. So this is a main part what we have in Germany. Energy from biogenic waste and residues. I will show you an overview in this chart. There you can see on the left side that we have a lot of residues in Germany. It's roughly 240 million tons of dry matter every year, and this, if you put it on a fresh matter base, it's roughly 400 million tons, and this is a truck chain 4 times around the globe every year in Germany. You can see on the left side, the main part is based on agricultural byproducts. We have the forestry byproducts, and above you can see the more waste-related waste streams. And on the right side, you can see what we do right now with this part. And we have a lot of possibilities to optimize this system. There we are working for at the university and also at the DVFZ. Some examples in the next slide. The first, some words about animal farming in Germany. You can see here the slurry and manure from livestock in Germany, the resource potentials, and the technical potential is roughly 14 million tons of dry matter. The current utilization is only below 5 million tons, so 9 million tons. We have to optimize the treatment in the future, and there we are running some projects for Germany. One possibility for this substrate is to use it in biogas plants. Right now, we have roughly 10,000 biogas plants all over Germany. And here you can see the main data: installed electrical capacity, roughly 6 gigawatt electricity. We have the gross electricity production of mainly 32 terawatt hours per year. And also we have heat supply, roughly 20 terawatt hours per year. Some words to the organic waste in Europe and especially in Germany. This is a chart for the European Union in general, and there you can see one problem we have in Europe. We have the household waste and only a separate collection of 40% of the bio waste, and 60% are going directly to landfill sites or in incineration. Both is not sustainable. So we need to increase in Europe and also in Germany the separate collection of bio-waste. The separate collection of bio-waste is only one possibility what we implemented in Germany. You can see different bin systems. We have a separate collection of paper and cardboard, the lightweight packaging, and the brown bin you can see on the left side. This is a separate collection for kitchen and green waste we do since the last 30 years. The optimized handling and treatment system you can see here in a simplified graph. We have the organic waste of the households, and there we have a lot of kitchen waste. So a biogas plant is the first option. We have a fermentation and can produce biogas. This we can use for energy. After that, we have a composting facility, and you can see also gardening and park waste. There we have also woody biomass included. This we can separate and put in a biomass power plant to produce also electricity and heat. And after the composting of the gardening and park waste with the fermentation residues, we have a high quality compost for the agricultural area. This is a main project we have in Germany since 2008, and there we on the way to implement. Some information about the outlook, what we developed at the German Biomass Research Center, the so-called smart bioenergy concept, also with a focus on the residues in Germany. The first of all is the remark that biomass is a limited resource. 10 years ago, everyone in Germany said with biomass we can solve all the energy problems. This is nonsense. We can only produce 10–15% of the energy, but only then if we have first a solution for the food that we have to produce for the inhabitants of Germany. The second use must be a material use, also in a cascade, and after that and during this cascade use we have different residues, and this we can use for the energy production. The smart bioenergy concept, what we implement in Germany in the next 10 to 20 years. You can see both routes. Below you can see the energy route. We have different possibilities of renewable energies. We have a high standard of development in technical way, and the next years we have to implement an integrated energy system to combine wind, solar and bioenergy. And in the material route you can see here we are coming from the fossil route, and we want to create a bio-based economy in Germany and also a circular economy you can see on the right. So this is the goal we have latest in 2050 to implement, not only in Germany, we need in global scale. Some examples of what we are doing right now. You can see here the different biomass, also the bio waste. We put, as I mentioned, in 10,000 biogas plants, and then we have a combined heat and power unit, produce electricity and also heat, what we can use. The digestate, we go to a decanter, for example, and produce a fertilizer for the agriculture. This is a standard biogas plant we have in Germany, and this is the basic for the optimization in the next years. One point where we have to focus on in Germany is to produce energy, especially electrical energy, then when we use it, and this must be fill the gap of solar and wind power. So if they are not working, bioenergy must fill the grid, and therefore we need a flexible biogas production. And here you can see different possibilities where how we can optimize this the general system. And there we have a lot of projects running at the DBFZ and also at the University of Rostock. The other point is that we developed the biogas plant I showed you before, from a classical biogas plant to a biorefinery, that we can also extract different chemicals as basic for chemical industry and processes, and there we have also a lot of projects going on. Then I will come to the conclusion because the limited time of 15 minutes, there's only the possibility to give you some insights, and for deeper information you can keep in contact with me. We have on one hand a long-term version up to 2040, 2050. In 2040, I think we have to be ready in Germany that we have a 100% renewable energy system. Globally, we need 10 years more, I think, and the bigger issue is to create also a bio-based economy, and these both parts are the basic for a climate neutral society worldwide, what we need. So sustainable utilization of biomass, and there also with a focus on organic waste and residues is, from my point of view, a key element. On one hand, to integrate in the energy system, and also to have a sustainable bio-based economy or bioeconomy. In Germany, we are on track to implement in long term the sustainable circular economy, and also the 100% renewable energy system. But as I showed before in the slides, we have a very long way to go, and there we have to be more fast than in the past. I hope the new government we will get in the next week will focus more on these issues, and then we are on a good way, I think. On the other hand, I think it's very important to increase the international cooperation also between India and Europe, and therefore the conference is a very good basis. With these words, I will skip my presentation. Here you find some contact dates, and so I think I can finish. I have to this, and so I'm nearly in time.
Thank you very much. It's really a very nice presentation. Comprehensively, within 15 minutes, you could cover entire spectrum of this bioenergy, Germany's progress, as well as this national and international requirements. And that is a really positive presentations. We'll get many ideas over here to begin with. As Nilesh says that he will be leaving for another 40 sessions. If any of our colleagues, any of your attendants presence here have any questions, specific questions for Nilesh, they may ask it now, and or otherwise the question sessions would have been taken at the end. But as Nilesh is leaving, maybe you can take some, if any quick questions from any one of you. You can write in the chat box. Our people will help. Or till then, I have a question here. How you could say that economy of this scale of economy, or this particularly economy of utilization of waste part to energy, in compared to these conventional sources? Otherwise, we have fossil resources. For example, electricity from coal versus electricity from this biogas, and then your fertilizers from this conventional sources versus from biowaste. As because all competitiveness is the main issue, how you could run over here, and then what could be the role of the governments and our public organizations, so that just quick response from you will help us to understand here.
is a very important issue what you mentioned, and this is only working if the price for fossil use increase, and this is a model we want to implement in Germany. And the new government, I think, will start next week, and they have a lot of these ideas. And if you use fossil fuels, it must be more expensive than to use renewable energy and new renewable resources. And then it will be working, and it's also interesting for the industry because they can earn money.
Good, very good, very good. So may I request Tuli to tell about this next presentation? Tuli, just unmute you and then tell us what is the status.
Bye.
Bye. Thank you very much. Tuli, could you please tell us how many presentations will be there?
Yeah, sir. I have already written in the chat box. So Francisco Di Maria will not be able to join. And after that, you go on by the list which has been provided to you, sir.
Okay. So then next will be evaluation of the results of chemical and microbiological analysis of soil and water of territory of some official and illegal landfills in Georgia. This and Wakize and Desbiskavi. May I request the Georgia team to present their or this?
They are there, sir.
Okay, thank you.
Hello, can you hear my voice normally?
Yeah.
Yeah, so, yeah, I'm Georgi Berechikidze. Good evening, first of all. And can you see my presentation, which I just shared?
It's visible.
Or PowerPoint presentation, but yeah, thank you.
Good, great. So yeah, once again, good evening. Like I said, I'm Georgi Berechikidze, and today I will be, I have an honor, so to say, of presenting the results of our research, which was the evaluation of the results of chemical and microbiological analysis of soil and water of territory of some official and illegal landfills of Georgia, which carried out under the grant project development of an integrated methodology for determination of the likelihood, that's one. Likelihood of emerging illegal dump sites in how mountainous rural regions on the example of Georgia. So briefly to say a few words about Georgia, where we are from originally. Georgia is a country of Transcaucasia located at the eastern end of the Black Sea on the southern flanks of the main crest of the Greater Caucasus Mountains. It is bounded on the north and northeast by Russia, and on the southeast by Azerbaijan, on the south by Armenia and Turkey, and on the west by Black Sea, as you can see on the map. The total population of country is approximately 4 million people, and about almost half of it, 1.3 million people, live in the capital, which is Tbilisi. So nowadays, the main part of the municipal solid waste is generated throughout our country without any sorting, and is placed in official or illegal landfills, so-called open landfills, which is approximately 90%. There are currently about 60 official landfills in Georgia and numerous small-scale 0.01 hectare each of illegal landfills. Just a second. There are currently about 60, I just said that. There are only 2 official managed landfills in Georgia, which were built according to the European standards, with installed landfill gas pipelines, so-called collectors, but there is no infrastructure for burning or utilization of methane from the gas collectors. So these gases are emitted to the atmospheric air without any cleaning processes. The main aim of our research was to study the ecology of 3 types of open landfills in Georgia and to compare their negative impact on the environment. So the largest, which is approximately 84 hectares in Georgia, and at the same time the official landfill, which was built in 2010 in accordance with the European standards, which serves the capital, Tbilisi, Norio landfill, which is 30 kilometers from the capital. All types of wastewater generated in the area of the landfill after partial treatment are connected to the sewer collector, from where it flows into the river. In the natural ravine of the right bank of river Noriheli and further along the river. A reverse osmosis system is installed to purify the leachate waters. The capacity of the existing reverse osmosis is 12 cubic meters per day, which is insufficient and urgent task to solve the problem because the treatment of the leachate water cannot be done in accordance with the legal norms for discharge into the sewerage systems. To solve this problem, the leachate from the sedimentation system is pumped to the surface of the operated waste disposal cell by using pumping machines. Therefore, in circulate sedimentation system landfill body, the main purpose of the activity is to avoid this sewerage system and the neutral surface water, river Noriheli. Noteworthy is the fact that the river circulation moistens the compacted waste, and of course it increases the activity of biochemical processes, both in the landfill body and in the soils of the surrounding areas. Old type Samtridia landfill, which was put into operation in 1985 and partially rehabilitated in 2013. The landfill is located on the right bank of the Rioni, 5 kilometers from Samtridia city, serves about 1,000 inhabitants approximately. The landfill has a leachate water collection system, as a result of which it circulates in the landfill area. The third type of the landfill, of an illegal landfill, approximately area of 8 cubic meters, quadratic meters, sorry, located in the village of Metehi, Chidakarti region, Caspian municipality. Sorry, not this one, yeah. So during 2020, samples of leachate water rivers and soil of the landfill's territories and the surrounding area of landfills were taken. Samples of leachate waters were taken at Norio landfill at the point of exit from the reverse osmosis system, which did not function at the moment. At the Samtridia landfill, a small stream of leachate water from the drainage and an illegal landfill was formed after the rain. The samples were determined: color, odor, pH, total suspended substances, electrical conductivity, COB, BOD, TPH, total nitrogen, total ferrum, zincum, and so on. Total confirmed. Surface water samples were taken at the adjacent territory of landfill area at 2 points along the river flow, before the landfill and after the landfill, where the pH, conductivity, total suspended substances, total nitrogen, and the total coliforms were collected. Soil samples also were taken from the inner adjacent territory of the landfill at 4 points, at a depth of 20 centimeters. The samples determined the content of heavy metals and total hydrocarbons. So this table shows us the results of chemical and microbiological analysis of leachate water of the biggest municipal solid waste landfill. So as you can see, it's obvious that the concentration of COD in the leachate water of the Norio landfill exceeds the requirements of the European directive by 46 times, and the maximum admissible discharge by 178 times. As for the content of BOD5, it exceeded the requirements of the European Directive 16 times and the MAD 66 times. The content of total nitrogen in the leachate water, the concentration of which exceeds the data of both normatives about 104 times, was also found to be particularly high. Microbiological results are also dramatically high. Yeah, sadly. Total coliforms, 1,500,000, and equally 67,000 units per liter of leachate water. The results obtained by themselves show how actively a number of chemical and biological processes are taking place in the landfill area. This table shows the results of chemical and microbiological analysis of the leachate water of the regular illegal landfill in Georgia, so-called. As for the effects of illegal landfill leachate water, the degree of population in it is relatively less, but also does not meet the requirements of both European directives and the MAD. For example, the COD exceeds the European directives by 7 times and MAD by 27 times, while the concentrations of the BOD5 by the first case are more than 5 times and exceed the normative of the MAD by 21 times. Therefore, it can be said that both types of landfills have a negative impact on the processes of pollution of the surrounding areas and the environment in general. It should also be noted that all types of landfills create to some extent a number of risk factors in relation to the health of the population. So next table shows us the results of chemical and biological analysis of river Noriheve, which flows close to the Norio landfill. The obtained results show that the river Noriheve is not under the load of leachate water from Norio landfill because the circulation of the leachate water is effective yet, though there is a high risk of environmental pollution, which is mainly due to high probability of emerging discharge of the leachate water, namely in the case of heavy precipitation, water bodies, sedimentation systems are the most likely to overflow and discharge contaminated water into the sewerage collector and then to the river Noriheve and finally to the transboundary river Tklari, which is the main river of the country, so to say. But at this moment, therefore, we can say that the other type of sewerage water, which generates the Norio landfill treatment, is done with the norms. These graphs show the results of contents of some heavy metals in soil samples taken from territory of Samtredia polygon and the illegal landfill of village Metehi, which clearly shows how different the degree of pollution in Samtredia landfill and illegal landfill soils. I hope I'm not speaking too fast. In conclusion, the condition of the leachate water generated at all types of landfills in Georgia does not meet the requirements of both European and local normatives, which is why both official and illegal landfills have a negative impact on the ecosystem of the surrounding areas and play a major role in their pollution, sadly. The data which was obtained from the soil survey of the study landfills are quite different. In particular, the content of soils of Samtredia landfill with heavy metals is much higher than their content at illegal landfills samples. So based on the results obtained, the negative impacts of all types of landfills in Georgia, both on wastewater and soil, depends only on the area of the landfill, the volume of the landfill body, and the specifics and amount of waste. The circumstance is caused by the non-existence or malfunction of the sewage treatment system at the official landfills. In the end, I would like to thank you for listening to me, and also I would like to thank the Shotaru National Science Foundation for financing the support of this project. Yeah, thanks for your attention. I hope I was not too fast.
It's a really fantastic presentation. I congratulate you and all your team members from the Georgia Technical University. Very nicely you have presented your work, very nicely done work, and you deserve an appreciation. Now, I request the organizers whether we'll go for questions or we'll take the questions at the end.
So we will go for the questions at the last.
Okay, thank you. Thank you. Thank you. Go to this next speaker.
Yeah, Dr. Hilda is there, right?
Dr. Farkas Hilda, Embassy of Hungary in India. Hungarian Research Potential in Waste Management. Yes. Hilda Farkas. So, you are requested to present.
Yes, please, I try to share my presentation. Good morning, good afternoon, good evening, everybody. Can you see my presentation?
Stop.
Yes.
Yes.
Yes. Now I guess you can see. So, greetings from New Delhi, from the Hungarian embassy. Thank you very much, first of all, inviting me for that conference. My presentation will be not focusing so much on a research paper, on a research results, but I would like to show more about the Hungarian researcher activities concerning circular economy. So, as a good diplomat, I always try to start with bilateral agreements. Just picking up the keywords, we have agreement between Hungary and India on education exchange program. We also have a common science and technology cooperation agreement, which grants joint research activities between the countries, which is very important because out of the 4 focus areas, 3 of them are belonging to the circular economy. And we also have a waste management agreement with India. And last but not least, we also actively participating in the EU-India Water Partnership. Some words about the education cooperation. We have a very wide student and research and postdoc mobility programs. The first is Study in Hungary program. I would like to not speak too much about this. The only thing is that more than 550 study programs are available in English, mainly in English, in different degree levels. So it's very popular. Under this program, we also have a government initiative on Stipendium Hungaricum scholarship program, which is very good because 200 places are given to Indian students every year for enjoying the full-time scholarship. And the good news is that the call is open now until middle of January. So I would like to ask the students to join the program. And also we have partial study programs, mainly for PhD and researchers and postdocs, which is between 3 and 10 months, and also offer some summer courses, and this call will be published in January. Now, under the Stipendium Hungaricum scholarship program, as I mentioned, 200 places are available for Indian students. Then the application number is very high, 5 times higher than the places. But among them, among the available courses, there are lots of more than 40 different type of environmental related studies. And here you can see the important universities, the biggest universities, which offer circular economy related different courses. As I mentioned, a very important thing is that we have built a bilateral research program. The aim is to grant collaborative research projects, which can be performed by Indian and Hungarian researcher consortium. The focus area is biotechnology, water, energy, and the partners for that cooperation, Indian partner is DST, and the budget is very good. Project duration is 3 years, and almost very good. Always the same very good news is that the next call will be published this month. So I would like to call attention of the Indian researchers to follow the DST website when the publication will be available very soon, I hope. So just an example about the research projects. I do not like to read it all, but you can have a picture which Hungarian institutions and which Indian universities are mainly active within this bilateral research program. And you also have a picture about the subject of the projects. And now I would like to give some sentence about the science parks, because this is one we develop very intensively now in Hungary. which means that these science parks have a very special focus area. And I have to say that mainly they are attached to the main universities around the countries. Almost all of them can deal with some aspects of circular economy, but I would like to mention two main points, because at University of Miskolc, the Science Park deals mainly with material sciences, sustainability, waste projects. This is one important to our subject today. And the other one is, which is under the Pannon University and located in Nagykanizsa. Don't try to say the word because very difficult, but Nagykanizsa is a small town. And there is a really circular economy focused research and science park here. So I will give some details on that later. So now I would like to concentrate on three circular economy related science parks. As I mentioned, one of the center is attached to University of Miskolc. Their research area is material science, waste and sustainability. And I also put the contact person's email here in case you are interested to come and to contact them. The other is under the Pannon University Circular Economy Science Park. They focus on circular economy, of course, waste-related research, renewable energy, water, wastewater. So they cover all the area belonging to circular economy. And you also can find the contact person's email. And last, I would like to say some work about Biosalt and Applied Research Ltd, which is private research network. Let's say they are focusing on circular economy, agricultural research, biotechnology, material and structure testing, intelligent systems, and very specifically on certification of such kind of circular economy related technologies. So coming to the details, as mentioned, University of Miskolc, and especially Faculty of Earth Science and Engineering is the main focus point here. Because they have a center of excellence on sustainable natural resources management. So they are focusing on raw materials, also on renewable energy research, geoinformation processing, water resources, and sustainability. So you can find here the website of this faculty, and you can find a lot of cooperation partners if you will visit this website. And now what happened? Can you hear me? Us. Yes. So yes. And the next one is a Circular Economy Science Park, which is located in this very difficult named Nagykanizsa. I have to say that this is not 100% ready yet, but they are now started in operation. Of course, they have some flagship projects. And they also would like to answer to some challenges, like as first, sustainable chemical industry. Under this point, classification and waste recycling is the main point. So they would like to develop technologies and methodologies to get the sustainable chemicals from raw materials, and also they focus on low carbon fuels. The second challenge is belonging to the future of mobility. Here they focus on the e-batteries, solar panels, and electronic devices recycling, with special attention to the lithium content. The third challenge belongs to the renewable energy and energy security. Here, the main point is the green hydrogen, especially how to store and how to transport. And the last one is the water management, where industrial water recycling and special research and technology on microplastics are going on. So you can see the contact person here. Don't hesitate to send any letter or request to this gentleman if you are interested. I don't know why I cannot move the screen. But anyway, I try again. Something happened. So anyway, I have only 2 more slides, but I'm not able to move the screen further. Yes. My computer woke up. So the last research network, but I would like to show you, we call it Zoltán Applied Research Network. As you can see on the map of Hungary, they have a lot of units around the country. So this is a real research network, and I highlighted with blue, which relates to circular economy. And also I highlighted their website link. So this company deals really with everything concerning circular economy, especially that they have such kind of initiative. So they deal with waste management mainly, but not only with that, but environmental remediation, bioremediation, and also agricultural and farming procedures. So biotechnology, eco-design. So their portfolio is very, very wide. I really suggest to you, if you want to have a research partner here in Hungary, Zoltán Applied Research Ltd is one of the best, where you can find a very good researchers, with very high potential of research publications and project activities. So I would like to suggest you to approach this company if you like to have a Hungarian partner. Let's see. So, and my last, if I will be able to have my last slide. slowly. Okay, so my last slide is just simple because I wanted to say that Hungary as a member of European Union, of course, all the Hungarian researchers are very keen to have Indian partners for establishing a collaborative project together with the EU member states concerning the Horizon Europe research program. And hopefully, I don't know what happened with my computer, but if the secretariat of this conference would be able to distribute my presentation, at the last slide you will find my
I can open the
contact.
presentation for you now. Kindly unshare that link so that I can share.
All right, thank you. So I'm really not able to move this presentation further.
Okay, I'm trying whether
at least I could.
I'm just
At
sharing
least I
this
could finalize
from my side.
Thank you very much for your kind attention.
Yes.
Let's see whether it's coming or not. Just see.
This is the last.
This is the last slide, ma'am.
Yeah, this was the last. Yes. You see, my computer tried to cheat me, but okay. So that was my last with my contact details. Thank you very much.
Yes, Dr. Hilda Farkas, really you have very nicely presented these Hungarian institutes and the possibilities of collaborations in India. Personally, I am really thankful to you because my university at present have a Hungarian or Indo-Hungarian projects going on, and you have already listed there. I'm happy to see it. I'm delighted, in fact. And we have a very nice experience, and we're hopeful that in this December 2021 call also, we will be attempting and will be successful. And I request other colleagues also here who have joined to give wide publicity, because this collaboration is really fruitful, and Hungary is a very friendly. The colleagues are very, very friendly, and we can see good works and good collaborations. And this I really thankful to Hilda Farkas for giving us a comprehensive overview of the academic opportunities in the areas of circular economy. With this, once again, thanks from all on behalf of these organizers. And maybe now we can move to next presentations, and then all the questions should be taken at the end. With this, I think we have next. This is Petro Barchar, Belgium, circular economy legislations in the European Union. Is he available? He is available. We can request him to Mr. Belgium presentation. It is good.
Sir, I'm not finding anyone right now. But then
go to next
forward, yeah, you just move on to the next one. If he joined, then he will deliver his speech at the end.
This is Liana.
No,
Georgia?
No, they will not presenting today.
Okay. Which one is the next one?
7th one.
Okay. There is assessment of global warming potentials of prospective HPPs in Georgia. Maka, this Hakarania, Georgia. Please. Maka and her colleagues to present.
It's my turn. Magajishkariani.
Yes.
Yeah.
Okay. Okay. Hello, everyone. I would like to present my presentation about assessment of global warming potential of prospective hydropower plants in Georgia. Georgia is my country, is located in the Caucasus region between Black and Caspian Seas. The capital is Tbilisi with population of 1.2 million people. I would like to make overview of planned hydropower plants of Georgia during 2022-2025. I would like to show perspective regulatory hydropower plants that is planned for the next 5 years. There is 4 big regulatory plants. We have several perspective seasonal hydropower plants that will be built in the next 5 years. There is a perspective increase of load, white, yellow cycle, because this part of Georgia is more consuming region in Georgia. We have thermal power plant that is closed already in Gardabani, but we have new combined thermal power plants that is built, new power plants. This is new technologies, and this is required strengthening of neighboring systems. This neighboring systems between Azerbaijan and Turkey and between Russia required strengthening of intro system lines. Intro Georgia parts of this existed strong general generation region and strong consumption region. The government of Georgia plans to build regulatory hydropower plants the next 5 years. That is Namakhvani, Neskra, Khudoni, Oni, Cascade. A part of this, the government plans to build several seasonal hydropower plants that have reservoir. The aim of the research is identify the most greenhouse gases emissions and consequently the negative impact on the environment. The hydropower reservoir is changing the local microclimate. The result is increased humidity, increased average winter temperatures, reduces the land area, covers it with water, and makes it unusable for agricultural use. Cooler summers and frequent fog. Hydropower plants reservoir of infrastructure leads to less of real estate for the local population and of source of income from Arab of moving land. Often the construction sites of the hydropower plants included villages, historic buildings, churches, and cemeteries. Hydropower plants have their own global warming potential, and emission gases of this, such as carbon dioxide, methane, nitrogen suboxide. We calculated greenhouse gases of potential hydropower plants that have reservoir. The calculation performed according to the guideline document of the Intergovernmental Panel on Climate Change. And we used these formulas to calculate greenhouse gas emissions. There is shown Georgian potential our hydropower plants, floodplain area, and greenhouse gas emissions. There is this hydropower plants that is planned capacity, installed capacity, flooded area in hectares, which will be flooded. It's CO2 emissions, greenhouse emissions, and this is shown total emissions in tons in equivalent. Expected greenhouse gas emissions as a percentage of planned hydropower plant shows that the most will be from Namakhvani hydropower plant. Research results. Finally, calculation shows that the largest area of greenhouse gases emitted from Namakwane hydropower plant, 29% from Udoni hydropower plant, and 21% from Neskra hydropower plant. Conclusion. I recommend the following measures: diversification of electricity generation, study of country's potential regarding alternative energy sources and promotion of their implementation, solar energy potential, wind energy potential, biomass energy potential, geothermal energy potential must be reduced negative impacts on biodiversity, protected areas, and forests. It is advisable to conduct forest ecosystem impact assessment also, to forest habitat restoration. Thank you for your attention.
Thank you very much. Very nice presentation, particularly providing us an insight of this global warming potential, climate change, or emission, particularly with reference to the hydropower potential power in Georgia. Good results also presented. I congratulate you. And discussions or questions may be taken at the end of the presentation. And I request colleague Tuli tell us about the next presenters who will present. Is it Dr. Samarjit, right? Number 8?
Sir. It's Dr. Samarjit Rao.
Okay.
Yeah.
We request Mr. Roy.
Hi, good afternoon.
Sir, it's there, yeah.
Yeah. Thank you for inviting me. And I'm a old member of the IconSWM. I've been there for last 9 years. I've made a presentation on waste to energy. This year, my theme is a bit different. And different because of the COVID situation, I thought I'll bring something to the table which needs real attention, actually. So my title of the topic is Secret of Making Oxygen from Air. So that is my title. You may think it's relevant, you may not think it is not relevant, but once I make the presentation, you'll see the presentation, why I made it and why I made it now. Now, the thing is that, secret of making oxygen from air is not a new technology. It has been, it was invented by Mr. Linde, Carol von Linde in 1895. And it has been used widely, but in India, it has not that, developed for some reason. So I would like to highlight that. And if I can share my screen, just a minute. Yeah, can I see it?
Not yet.
Not yet.
Maybe it comes.
Not yet.
Yeah. I don't know why I can't share it now. No, sorry, I can't get in touch actually.
May I request Tuli, if you have a copy, you can help him to present. Do you have
Yes, yes, I'm just seeing whether I have that copy of Sir or not.
Yes,
yeah.
yes.
Actually, if you can find it.
Yeah,
Thank you.
Sir, I am providing you one mail ID. Kindly mail your PPT on that mail ID, please. Because I'm not having your PPT right now, sir. So I am just giving the mail ID the chat box. You kindly send it that mail. Okay.
Okay. Thank you.
Is it okay for you, sir?
Yeah, that's fine.
Yeah.
Have you sent it to my email?
Are you sharing your screen?
Just 1 minute, I lost everything.
I think, sir, you have shared your screen. Dr. Samarjit Roy, sir, are you there? Yeah, I think, sir, your screen is visible right now. Can you open your PPT? Yeah. It's coming, sir. Yes, sir.
Can you
It's
see it
visible.
now?
Yeah,
Can you
yeah.
see it? Yeah.
Yeah. Sir, kindly make it into full screen, sir.
Yeah.
Sir, you PPT?
I can see it on my screen.
Yes, sir. At the end, sir, there is a screen. At the left hand side, sir, you can see. There is a icon like what do you call it? A glass.
And,
No, so it's a full screen mode. You can see that option. Or F5.
Excuse me.
Or
I
F5.
think it is better if the Mr. Raha is use PDF file, so it is easier to present and it is not too that heavy for internet
can you see the
connection.
can you see the PPT?
Yes,
Please go ahead.
yes.
We can see,
Yeah,
please
yeah.
go ahead.
You can go ahead, sir. We have no problem.
Okay,
Yeah,
that's
your screen
fine.
is visible right now. Yeah.
Sorry about that. So making oxygen generators separate oxygen from air so that the gas can be fed into industrial processes in real time or stored in pressure tanks. Oxygen generators are used in dozens of industrial applications ranging from gold mining to aquaculture to life support. Now, this is very simple because clean air is made up of 78% nitrogen and 21% oxygen and other trace gases like argon and carbon dioxide. So the trick is that if you can remove the nitrogen, then you are left with mostly oxygen, which is 21%. So you can use it. That is the trick. Now, businesses who need bulk oxygen often start by purchasing tanks from other companies who fill those tanks using an industrial oxygen generator. If the need is large and ongoing, it may be cost effective for businesses to purchase their own oxygen generator and produce oxygen on site. While upfront cost of the machinery is significant, the cost per cubic feet of oxygen generator is 1/3 or 1/2 of the purchasing bulk oxygen. So over the time, oxygen generators can pay for itself. Now, producing on-site is the solution. It protects from supply shortages and associated losses of oxygen supply at the hospital. Supply losses happens, as you know, from electricity. When this transfer electricity long distance, it loses some power. same with oxygen. If you supply oxygen from a distant source, you lose some oxygen in transportation. It is very important in remote or hard to access areas. It is often not possible to ensure the oxygen supply through the delivery of oxygen. And I'll come to this point later on, because that is the main reason I have chosen this subject. So please remember, particularly in remote or hard to access areas, it is often not possible to ensure the oxygen supply through the delivery of oxygen. Now, advantages of oxygen on site plant: no carbon dioxide pollution for the environment, no hazardous goods, no risk of explosion, in-house placement and production, and obviously oxygen at any time. So you can switch on the oxygen line maybe 2 o'clock in the morning. And it's obviously cost effective, and it is very sophisticated technology. Now I'll come to the, as I said, it is not a technology, and you'll be surprised that there are 6 different processes of producing oxygen at home. And I'll go through briefly all 6 processes. The most important one is the pressure swing absorption oxygen generators. Now, PSA generators generate nitrogen from ambient air inside a pressurized tank filled with zeolite. Zeolite is a natural made mineral that acts as a molecular sieve. So it acts like a sieve. So what happens if we pass the air from one side, and that molecular sieve will hold all nitrogen, and nitrogen is molecules are absorbed, and you get oxygen on the other side. It's something like, you know, liquid stream. So this is very, very known technology, is used worldwide, and it is very economical. As I said, PSA, this is a compressed air flows from 2 absorption vessels filled with zeolite, and in the generator, nitrogen and carbon dioxide molecules from the ambient air are caught in the sieve, while the free oxygen molecules flow into the product tanks, and it can produce 5 cubic meter dry oxygen with a purity of 93%. Obviously, 5 cubic meter, it depends on the size of the plant. You can increase it, you can double it, triple it as you require. Second method is vacuum swing absorption. And if you look at the picture, you see 2 pictures. So what happens, the vacuum is created, and if you look at the bottom of the left-hand one, the air goes in, and on the top, you'll see the oxygen comes out because of the vacuum situation, and the rest of the air comes out to the E zone. And if you reverse it, this is a vacuum resistant. You pressurize once and you lose the pressure again. So in both process, you on the right hand side, when you ease the pressure, again oxygen is produced. And to be honest, there's no reason you cannot separate nitrogen as well for other uses. It is very simple because most of it is nitrogen. So if you need nitrogen for some use, which normally you have to buy, you can separate nitrogen. But this process is mainly for getting oxygen from air. Second or third one is the fractioning column. Fractioning column is also very, very widely used worldwide. Fractional column is essentially an item used in the distillation of liquid mixture to separate the mixture into component parts. That means you liquefy it, and then when you try to release it, what happens? A different fraction of the gas comes out at different times, depending on the volatility, volatilities. So fractioning columns are used in small-scale laboratory distillation as well as large-scale industrial distillations. The other one is chemical oxygen generator. Chemical oxygen generator works in a peculiar way. You burn something and you get oxygen. So what happens? a container of organic salts called superoxide or sodium chlorate are ignited. And when they are ignited, as the heat they give off oxygen until the compound is completely consumed. So what you do, you heat this sodium chlorate, ignite it, and it gives off oxygen until all the sodium chlorate is consumed. The one of the other one, as you can guess, is a membrane oxygen generator. Membrane is used in many technologies in waste to energy, and when you produce biogas, it's widely used. Membrane is very popular in India as well. It's used by many of the pharmaceutical companies. What happens? Membrane oxygen generators use a compressed air stream passed through the semi-permeable material that allows for the passage of specific molecules. So under pressure, small oxygen molecules pass through the membrane, filtered out and collected, leaving stream of nitrogen. Again, what happens? The nitrogen is held on the other side, or the input side of the membrane, and output is oxygen. So you can easily collect the oxygen. It is pure oxygen. While membrane type generators are not as common as they're more reliable, because they're actually more reliable because there's no moving part. In all other processes that I mentioned, there are some moving parts, but in membrane type generators, like any other chemical process where one uses membrane, there's no moving part, and it's very simple. You just like a sieve, it works like a sieve. So anything bigger molecules is held, and then obviously you have to select the membrane for the purpose. Now, last but not least is a cryogenic distillation process. Cryogenic distillation process is also, you can see how in the diagram oxygen is 20.95, which is about 21%, and nitrogen 90%, and all other gases are in minute scale. Pure gases can be separated from air by first cooling it until it liquefies. So what happens? The gases are cooled, and then selectively distilling the compounds at their various boiling temperatures. So they are cooled and then they are heated up, and different gases comes out at different time. And the process can produce high purity gases, but is energy intensive. So it consumes a lot of energy. That's why it is not all that common, but large industry benefit because they can get a lot of oxygen in a small time. And this is the one I said that this process was pioneered by Carl von Linde in early 20th century, and is still used today to produce high purity gases. So it is used industrially even today. Although he developed in 1895, the process remained purely academic. A lot of people will know his name, Carl von Linde. Anyone who studies chemistry will know that. But he developed in 1895, and a first application was made in 1902, and this is still being used because it's simple process, and it separates. You get pure oxygen with compared to other things. Now, composition of dry atmospheric air, that is the source. That is source, and pure gases can be separated from air by first cooling it until it liquefies, then selectively distilling the components at their various boiling temperatures. That's what I explained before. This process can produce high purity gases, but is energy intensive, as I said before. It is also used in industry at the moment extensively. Now I come to a specific technology, which is INMATEC PSA technology. This is a German company PSA technology. They produce PSA technology, membrane technology of a solution, and they meet the needs of the customers of all sizes. As you can see in the picture, they make huge plants and they export to various countries. And the generator POC made series meet international standards and deliver medical oxygen for COVID treatment. And that's why I brought this subject. They have been used widely worldwide, but you'll be surprised to know that INMAC technology sees is a state-of-the-art network, is a measurement of monitoring all operating values, ensuring the high possible protection of the entire production process. So it's very, very safe process. And the process is called plug and play. So you can buy a machine and you can just plug it and you'll get the pure oxygen from air. So there's nothing technical, anybody can fit it. And they are very, very popular. And as I said, they're a German company, and we had a lot of interaction with them during the COVID. And they supplied 91 plants to India. And in this picture, you say the Mohit Jadhav, who is the consular in Germany, he himself ordered, and he got 91 at a very, very critical time when there shortage of oxygen everywhere in India, small, big hospital, and any health institution were running short of oxygen because they had no means of producing bulk oxygen, which was needed at that time. INMATEC delivered to India 96. You can see small was they, within a short space of time, they delivered 96 oxygen generators for India's hospitals. And Mohit Jadhav, who is based in Germany, is Consul General, and he was instrumental in seeing that that process is done very, very speedily. And my contact, Dr. Peter Wiedencroft, he is the general manager of that INMATEC technology. He has actually been in touch with me last year. With full wisdom of Modi, what he said that he is ordering, 55 INMATEC about a year ago, just over a year ago, and he wanted to deliver the first one to Kashmir, Jammu and Kashmir, and they face logistic problem because there's no flight nearby where they can fly, and the road is not all the safe. And at that time, we were talking, and he was suggesting if I know any transportation company near Delhi or nearby, which I didn't know. But you'll be surprised that just about this time last year, he managed to deliver the first one to Kashmir, and followed that with 55 others. And within a very short space of time, I think 6 to 8 months, they supplied another 41 large systems. And as a result, liquid oxygen, many hospitals in Central Europe, they are also demanding because Germany doesn't only supply India, they were supplying to other countries as well. And these are not, scalable. You can't suddenly make 100 units in a month or two. But they managed to do it because of the crisis they were suffering, and they wanted to help India very much. They were aware about that, 1.4 billion inhabitants from India, and they saw some horrible images, people gasping for air, and grieving relatives are going through the world. And I have friends and associated who suffered exactly that, that they were gasping for oxygen and they couldn't. And my brother-in-law had a attack, and his daughter spent about 8 hours in a car to find a hospital. Eventually, they found a hospital near Dum Dum. They live in Taliganj. and the only condition that she has to bring her own oxygen. That was a reality, and that's to close the story. It successfully he recovered, and she found oxygen. So industrial oxygen generators are used in also steel manufacturing process. Several oxygen furnaces are used for decarburizing. I'm basically a metallurgist, and my first job was in steel industry, and I used to instruct the workshop people how much oxygen they use to decarbonize. So to reduce the carbon, we used to get the analysis from chemists, and I used to tell them how much oxygen they must blow to bring it to the specification. That is a real science we have used actually. That has a use, and also mines that extract golds on industrial scale use oxygen generator during the cyanide leaching process. Cyanide leaching process is also familiar with many chemical students, chemistry students, and chemical engineering students. Sodium cyanide solution is mixed into crushed gold-bearing rocks along with oxygen to release the gold from the rock. So that process is widely used worldwide. Welding, again, being a metallurgist, I've been involved with a lot of welding activities because that's what you do when you're in industry. So, I've been in automobile industry, and there's a lot of welding goes. You can see spark flying all over the factory. So that is heavily used, and they only need oxygen. All the cutting and welding machines are oxygen dependent, so you have to have pure oxygen there. Melting and welding or cutting of the metal, oxygen is needed very much. Now, enclosed areas with higher than normal level of oxygen are typically not medical hazard, but do increase the risk of fire. That fire risk has to be accounted for, and all safety precaution has to be done, because this pure oxygen will burn like anything. Even 2 to 3% increase in normal room oxygen level when combined with fuel, a spark can result in a small spark. If you got a small amount of oxygen in the environment, and if you got a small spark, that can flash a fire. So you have to be mindful of that fact. Effect of shortage of oxygen during treatment of COVID-19. In February 2020, the World Health Organization designated the disease COVID-19, which stands for coronavirus disease 2019. The virus that causes COVID-19 is designed severe acute respiratory syndrome coronavirus. That's what the actual description. So it is a acute respiratory syndrome coronavirus. That's what the main problem. It's not any other thing. People suffering from COVID grasp for oxygen, grasp for air, and it must be supplied at the point of medication or hospital where they have been treated. It is known to have large genetic diversity and rapid evolution. So this genetic disease, as you can see, is spreading. So we must not ignore the production of oxygen, how important it is. Now, also another medical procedure use is ozone therapy. Ozone O3 is the triatomic allotropic form of oxygen. Its oxygen potency is higher than oxygen. So O2, obviously, you can see O3 has got more potency of oxygen. Ozone therapy in the medical setting employs a gas mixture of oxygen and O3. That means oxygen and ozone obtained from the modification of medical grade oxygen using an ozone. So you can modify the oxygen to make it ozone, and that used as a combination, because oxygen you need for breathing and oxygen, ozone you need for the treatment of certain type of alignment. This has to be placed in situ because you cannot have oxygen supply and ozone supply a different different pipeline or different factory. So it has to be, if there is a need, you have to have it in place beforehand. Usual clinical ozone concentration range from 10 to 60 microgram per millimeter using oxygen as vehicle. So oxygen is used as a carrier. So it is the main treatment is using ozone, but oxygen is used as a carrier to get to the point of heart or brain or wherever it is needed. The main mechanism of oxygen and ozone on human psychology fits the concept of oxidative preconditioning. So to get oxygen is needed in the body, and that's why you survive, because it filters blood and it circulates everything throughout the body. But to precondition that oxygen shortage, you need to use ozone therapy. That is the purpose of it. So it gets some sort of lubrication effect. It lubricates the flow of oxygen.
Sorry to interrupt you, sir.
Yes,
Your
that's
time is
fine.
over.
And Dr. Birenkov knew about my presentation and he wished me good luck. And I thank you for watching this. And if any question, I will answer. Thank you very much.
Thank you very much, Dr. Rai. This is really a good and presentations which have very your importance considering the time that you're passing. Oxygen, we understand the importance of oxygen, but when we realize after the COVID that oxygen has been a cause for your crisis, that was not much realized before the COVID. We understand the importance of oxygen, and you have very nicely presented the different modes and methods of getting oxygen and industrial overview, as well as your chemical, your engineering background also you have given. It's a really nice presentation. I congratulate you for bringing all these things here for our considerations and importance for not only for medical but also for other areas. How oxygen is important could be taken care. What are your technological status at present? Very nicely you have presented. We thank you for presentations.
Thank you.
Now I request this all presentations now open for discussions. I request my colleague Tuli to take care of these discussions. How we will take care?
Yeah, I would like all participants kindly write your question in the chat box so that our chair can answer or relay the question to the presenters who are there. Dr. Samarjit Ram itself kindly unshare his screen.
Yeah, okay.
If you please answer your slides, Dr. Ray. And also, I request other colleagues, the other presenters, or who have attended this session, if you have specific questions for anyone of the presenters, or maybe your observations, comments in this regards, will be welcome. Welcome those your inputs, including questions. If we don't have any questions, maybe this presentation is too nice, and then everything was very clear. No specific questions. If not, I think we can summarize the session. Tuli?
Sir, you are requested to do that thing, sir.
Okay. Okay. So we have 5 presentations here. First presentations on organic waste and residues in Germany, the role in the energy systems, bioeconomy, and climate change. Very nicely, Dr. Michael Nellis has justified or the overview of this organic waste, the practices in Germany. Different considerations, different technological aspects are covered fully, and also conclusions were nice. What would be the roadmap of 2050? What is the importance of collaborations, particularly international collaborations? And this is very nicely presented. The next presentation was impact of waste incineration. This was not presented, maybe due to some reasons the presenter was not available. And then the paper number 3, which is the third presentation presented at second slot, that is evaluation of the results of chemical and microbiological analysis of soil and water territory of some official and illegal landfills in Georgia. The Georgia Technical University presentations by NGUYEN and his colleague. It's a really nice presentations. Provided the overview of those landfills categorized, classified into 3 groups, and then a brief summary of the methodology, how they have determined, estimated different parameters, what are the different parameters, and what is the impact of these landfills on the land, water, and the environment. Very nicely with facts and figures presented. These are also very nice presentations, and it will really helpful for the policymakers for those technology development as well as economic importance. It's a very nice presentation. Dr. Focus Hilla, from the Embassy of Hungary in India, really nicely presented the Hungarian research potential in waste management, a particular attention to the circular economy side, an overview of the entire research spectrum which are available here, overview of those institutes, their contact address, the areas, very nicely presented, and it will be very fruitful for most of us. The circular economy in Belgian legislation, we missed it. However, the next pardon? This I think we missed it. It was not presented here. Okay. The next one, consideration of the climate change in protections of the environment in Georgia, also missed. However, assessment of global warming potential or prospective hydropower plants in Georgia, very nicely presented. What are the different aspects and of these greenhouse gas emissions potentials, different hydropower plants, and this will be very useful for policymakers to understand and how can you make a comprehensive plan of it. And the final presentation by Dr. Samarjit Ray, that is secrets of making oxygen from air, a overview, technological overview, usefulness, and the details of this status up to your latest status have been presented. This will also be useful for the researchers as well as for these uses at different points. I thank you all the presenters. I also thank the organizers giving me an extempore your chance, appointing me as an sharing, giving me a chance to share. And I have seen the original share, the actual share, and I request my colleague, my friend, Professor Chadan Ghosh, to take the share and then conclude it. Thank you very much.
You have chaired the whole session, and with a number of stalwarts having presentation, starting with Hilda, Dr. Roy, Maka Jiskariani. I want to see the face of Jiskariani, Maka, because we did not meet each other. Oh, I see. Great to see you. And I'm quite
Nice
sure
to see
that,
you.
because we know that we have a joint publication,
Yes.
one or two, yeah, and we are also doing more publication jointly. But this is the first time we are meeting each other. And I'm very
you very
happy
much.
that, yeah, I'm very happy that you and your researcher join. And I can also see Kochikoti Banda. He's a very active person in Zambia. And he is also working in waste management in Zambia and having a very good work and working group. He is also an active member in the working group of our IconSWM for the country specific. And you know that I'm not going into the technical presentations or the matter what has been presented here. But I heard and I have seen all the presentations earlier that there are quite a lot of educative material in each of the sessions and here also. But one more important thing which I like to highlight, that the matter which was presented by Hilda, that is different from the technology and also the awareness, but that is to support the researchers from Indo-Hungarian or any other country, European, so that researchers can do research with funding from that agency. So he is a person whom I request all the researchers to keep in touch with her, because she is a very resourceful person. And that's why I brought her here to make some info, to give some information so that it will be helpful for the researchers. The researchers mean not only the early bird researcher, but also the professors, lecturers, reader, whatever are their assistant professors. With respect to Dr. Roy, he is a very senior member in our IconSWM movement. From UK, he is always working with us, and whenever it is there, he comes to India, be with us, and do a lot of work for the conference as well as for the technology. He is at this age, he is nearing to 80. Of course, there are many lady members, so I'm quite sure that you will not tell us the exact age of you. So at the age of 78, 79, he is still moving like a very young star. So I congratulate you at this age. You are doing a lot of work. And we have a new friend, Si Liu from China, but he is very recently came across in our team of circular economy activity. And hi. And he is the author of one of my books on circular economy, which will be published in 2022. And those are in the process. So thank you, see you. And from now onwards, you will be our team member. And another person who is very active from Indonesia is Fatima, Woon Fatima. I don't know whether Woon has a presentation here or not, but she's...
Professor,
Hi.
I will present my my presentation today.
In ASEAN.
Yes.
Yeah, ASEAN. I remember now.
Yeah, thank you very much.
So she is also a very active researcher in Indonesia. So it's a conglomeration of all stars of research from various countries. I'm very happy to see you all. Of course, there are other friends from different countries, like I can see our friend Georgie. He is also from Georgia, Abhishek, and some friends from Philippines. I don't know who are. And Maya, Maya was in the trial run with us. So, yeah. Thank you very much. I don't take much time, but I congratulate you all and thank you very much for your participation in this very big movement, because you know that next year our conference will be in in India, a very big place which is called Tirupati, which was announced in inaugural session. And I wish all of us will meet physically over there, and you arrange all of, your travel, your stay and all these things. Probably we will be giving you free stay at the guest house or nearby. So you please arrange so that we can meet each other. This is number one. Number two, we need good number of papers from each of your countries and collaborate as a working group member in the IconSWM, like what Georgia has done, what Indonesia has done this year. So I request, Bangladesh did lesser this year, but because of number of problems. Banda from Zambia, they have also done a quite good job. Tunisia has quite a good job. So in that way, we will include you in our country-specific working group who are not in that. And we hope that 2022 will give us more input from researchers and practitioners for our next conference. With this, thank you very much once again for your patience and participation. Over to the Secretariat now, or over to the Chair, if you have saying anything.
Thank you very much. Already I have spoken from my side, and thank you once again and congratulate you. The nice presentations, all the 5 presentations were already, and useful informations have been delivered. It will really be useful for all of us. And then some of the presenters wish that their presentation files to be circulated, as it has good, inputs for academicians, for researchers, for students. And I thank you once again, because you have given me an opportunity to listen. This very useful and in different multi-directional areas. Thank you. Thank you once again.
Thank you, Devin. And my Secretariat requests all of you to show your nice face, putting your camera on, and they want to have a good picture of all. So please put on your camera who are not. Onaya, Maya, you please, Kochikoti, you please put on your camera. Yeah, it's good. So
Sure.
please take a photo. Hi. Yeah, Gregor. Thank you very much. All the certificates will be sent, and Chair, you please send the share summary and also the rating card in my email. So, wish you all the best, and whoever are not here in our working group, please let us know whether you want to be included in the working group or not. With this, thank you very much. Namaskar, Indian Namaskar.
Okay. Thank you very much. Namaskar.
Bye. Okay.
Okay.
See you again tomorrow. See you again tomorrow. Bye-bye.
Bye-bye.
Bye-bye.